Hi everyone, welcome back to my YouTube channel. I am Riti Kumari and I'm back with another video of the DBMS series. In this particular video, we would be talking about data models and types of data model. So without any further delay, let's get started. So data model. A data model within a DBMS, that is database management system, serves as an abstract representation of how data gets structured and organized within a database. It outlines the logical arrangement of data and connection between various data components. So it also plays a vital role in comprehending and shaping databases, acting as a vital link between real-world entities and actual storage of data within databases. So we read more about definition. Now let's see what is exactly data model. So let's understand what is flowchart first. So people who would be doing programming, they would be having a slight idea about flowchart. So in flowchart, what happens is we give some instructions like consider I don't know how to make Maggi, right? So I am making a flowchart on how to make Maggi. So basically in the flowchart, the very first thing would be to boil the water. Now the next thing would be to put noodles and masala. And much more thing. We are not here to learn how to make Maggi, but there are much more things, right? So we can consider it as flowchart or algorithm also. Okay? So there are many steps which is involved in making the flowchart as well as algorithm for making Maggi, right? So if we have the flowchart or if we have the algorithm with ourselves, it would be very easy for someone who doesn't know how to make Maggi. They can follow that particular instructions or follow that particular steps and make Maggi. So basically in this way only, flowchart helps very much. And data model is kind of, you can consider it as a flowchart where we get to know about like what all data would be there, what all relationship between the data would be there, what all constraints would be there, what are the attributes, what are the entities, and much more things. So let me just erase all these things. Okay, so now let's understand. So basically in the last lecture, we learnt about schema. Now here it is data model. Now in data model, what we do is we deal with data, then the relationship between data, and then the constraints. Okay. Now in schema also you would have heard I said some similar sort of thing, that it is kind of a blueprint of a database where we are dealing with data, relationship, and constraint. So you would be having a doubt, then what is the major difference between schema and data model? So data model is a conceptual framework. Or you can say an high level view. High level view of database. So basically in data model, we have a conceptual framework, or it is a high level view of database. Like there is a database, there would be such data in that particular database. The relationship between the data would be that. The constraint in the data would be that. So like there is a conceptual thing which is going on. Okay, so in a very high level, we tell that what is the data, what is the relationship between data, what are the constraints present in the database. But in schema, what happens schema is the implementation of a data model. So if I provide a data model, I can do the implementation using schema. So in schema, we basically do the implementation of the data model. So as I told that if you have a flowchart or algorithm of how to make Maggi, and if it is provided to you, you can make Maggi very easily. So in the data model, we provide a very high level view of our database, and in schema, it is basically implemented using all the given data, then the data, all the given information, and then there are data, then there are relationship, and then there are constraints. So data model is a conceptual framework or a very high level view of the database. Schema is basically the implementation of the data model. So there are various types of data model. So let's have a look. So one is hierarchical data model. The next is network data model. The third one is relational data model, which is very widely used. The fourth one is ER model, which is again very important from the point of interview and from the point of semester exams as well. Then the next one is object oriented data model, and the last one is NoSQL data model. So let's have a look about all these data models. So the very first data model is hierarchical data model. Are you remembering something? We heard about hierarchical inheritance, right? So basically hierarchical data model is somehow taking all those concepts, and we would be seeing that here as well. So in this particular model, it portrays the data in a manner that it is resembling like a tree-like structure where each record maintains a parent and child relationship. Its primary application lies in older database system. So basically in this particular model now, as we learned in hierarchical inheritance, so basically there is a parent-child relationship which is maintained. Each child would only have one particular parent. So every child would be having only single parent. There are no more parents for a particular child. So basically as you can see that here there is a child. The parent is school. So let's start from the top to bottom approach. So school is a parent. Now school is a parent, so it might have some childs. So now department and infrastructure are its child. Now coming to department. Now it is the child for school, but it might be a parent for its child, which is teacher, student and staff. So you can see there is a parent-child relationship which is maintained all throughout, and any of the child is not having more than one parent. So basically in hierarchical data model, there is a child which is having a single parent, and there is a tree-like data structure which is maintained. So this is kind of used in very older database, you can say as XML database, and it's not used very widely. But there is an enhancement of this particular database. So let's see the enhancement. So basically the next data model, which is also an enhancement to the hierarchical model, that is network data model. So this model shares similarities with the hierarchical approach, permitting records to hold multiple parent-child relationship. So there could be multiple parent-child relationship. One child could have many parents, one parent could have two childs, like there are multiple parent-child relationship which is maintained. It adopts a structure like graph. As you can see, a structure like graph is obtained, offering more flexibility compared to the hierarchical model. Again, in this particular model, one parent can have many childs and one child can have many parents. So in this particular model, there is more flexibility in compared to the hierarchical model. But again, this particular model is also not very widely used. So let's learn about the data model which is like very widely used. So the next model is the relational data model. About these data model, I guess we learned in the starting videos itself, but let's understand again. So organizing data into tables known as relation consisting of rows and columns characterizes the relational model. It stands as the most prevalent data model rooted in the principles and of the set theory and relies on structured query language for data manipulation. So basically, what is database? Database is kind of collection of interrelated data. So what does this term means? Interrelated data. So interrelated data means when data, like when the table are somehow interrelated with each other. Consider there is one table which is having details about student first name, last name, roll number. Consider second table which is having details about student subjects, then the co-curricular activities and much more things. So these two data have a relationship among them. They are mostly related to student only, student information only. So whenever there is like relation between two tables or two, you can take it in this way, table 1 and table 2. So whenever there is a relationship between two tables, it is called as relational data model. Now, basically it uses the structured query language for making queries like manipulation of data, insertion of data, deletion of data and much more things. Also, this relational data model is most widely used. Here you can see this particular table Table is also called as relation in database. Rows, which is also called as tuples, and columns, which is also called as attributes. And here there is a constraint which is called as primary key, which is a unique identifier. So this is a table which is also called as relation. That is why this is called as relational data model, because somehow there is some relationship between different relations, that is different tables. So collection of interrelated data is database, where there are many tables and all those tables have some relationship between them. So that is why we call this as relational data model. Now the fourth model is the entity relationship model, which is called as ER model. So it basically deals with entities and their relationships. Entities is also called as objects. So basically this data model is utilized for crafting relational databases. The ER model represents data through entities, attributes and relationships connecting these entities. So consider student is an entity. Now student might have some relationship, student studies, student is a enrolled student, and much more things. So basically the relationship which is defined here is study. Now student does study. Now student may have some attributes, like may have some properties. Key student have like student name, student roll number, student address, and much more things. So that is called as attribute. So basically it is student name, which is a attribute, like the property of the student. Entity is basically a single object. You can say student is an entity, or any real world entity or object could be used here. And then relationship, that what it does and what the relationship it has with other people as well, other things as well. So basically student might have a relationship with course, which is course is also altogether a new entity. So there might be some relationship, so that is represented here. Then there is entity, and then there is attribute, which is basically the entity properties. So the next data model is object-oriented data model. So object-oriented data model basically extends the principle of OOPS, that is object-oriented programming, into database domain, and this model depicts data as objects complete with attributes, methods, fostering support for inheritance and encapsulation. So consider that you have your front end which is written using OOPS. Now you want a backend which would be compatible with OOPS. So there this particular model come into picture. So it basically stores data in form of objects, and also it uses the object oriented programming principles. It is also helpful in achieving inheritance and encapsulation. Also in object-oriented data model, basically it is kind of a combination of object-oriented data model plus entity relationship data model, because in entity relationship data model, entity is treated as an object. Here also data is treated as an object. Now the next and the last data model is NoSQL data models. So basically in the NoSQL databases encompass a diverse array of data models such as document oriented data model, that is MongoDB, key value data model, that is Redis, column family, that is Cassandra, and graph, that is Neo4j. These models are designed to offer scalability and flexibility when handling extensive volumes of unstructured or semi-structured data. So basically NoSQL database models are something in which we don't use the SQL database for making queries. Also we don't use like it doesn't follows any traditional approach of relational data models. So in this data model, the data is stored in the form of key value pair. The complexity is a bit less, and also it is very scalable and can be used anywhere. So most popular NoSQL database which everyone uses is MongoDB. It is like very widely used, and it is also very helpful to fetch the data because again it is stored in key value pair, which is also using hash map for storing the data. So data independence is basically a fundamental concept with database design and management, emphasizing the distinction between the logical and the physical dimensions of data storage and administration in a database management system. This principle yields various benefits such as enhanced flexibility, heightened security, and simplified maintenance. Now, do you remember in the schema video as well and in the abstraction video as well, I told you about some levels like view level, conceptual or logical level, physical level. So if you are not remembering it right now, I have a picture about that as well. Yeah. So this is the diagram for the same. So basically, let's understand what is data independence and how it is helping us to achieve more flexibility and higher security and much more things. So basically, in data independence, what happens na, ki as you can see from the term data independence, so somehow we are making user independent of the data. So basically, data independence here means na ki at any level, either it be physical level, either it be logical level, either it be view level, at any level, if there is any change, it won't affect the other levels. So basically consider that there are three levels: physical, logical and view. Physical level basically deals on where the data is stored. Logical level basically deals on what data is stored. And view level basically deals on, you can say, virtual tables or views based on user requirements. So basically this is a brief about all the three levels. So in the physical level, we are majorly concerned about where our data is being stored. In the logical level, we are basically concerned about what data is being stored. And in the view level, according to the user requirements, we see some kind of virtual tables. Consider like I am working in a factory, right? So there would be many people in the factory. One would be a salesman, one would be someone who is looking into some other details in the factory. So for like each member, there would be some different database which would be shown to them. Also, we can take an example of library. Consider in library, there are many people, there are students, there are then library staffs, then there is a person who looks into all the databases. So for the students, there would be some data which would be visible. For the librarian, there would be data like when the student issued that particular book, what is that particular book, what is the price of that book, and much more things would be visible. And for the library, for the person who is looking mostly into the database or a higher level authority, they would be having access to the librarian data as well as the student data. So according to the requirements, like if I am a student, I want to see these particular fields in that particular database or that particular column in that particular database, so I can see that according to my user requirement. If someone who is a librarian, he or she wants to see that which student issued which book on which particular date, what is the price of that book, what is the student ID and much more thing, he or she can see that. So basically in the form of virtual tables, we get to know data according to the user requirements. So this is about all these three levels. So here data independence, what happened na, ki data independence says that if there is any change at physical level, there won't be any impact at the logical level. So if we are making any change in the physical level, the logical level won't be impacted. So basically this is also called as physical data independence. So in physical data independence, it says that ki any change which is happening at the physical level, it won't affect the logical level. Let's understand it from an example. So let me just erase everything, and then we will see the example. So yeah, okay, so physical data independence. So consider that let's take an example of book. Okay, so there is a database of book. Okay, consider that right now it is stored in a hard disk. The database is stored in a hard disk, like the number of books which is available at a particular library. Now consider one day, since there is like lot of database, we thought to move it from hard disk to cloud storage. So basically earlier the database used to reside in the hard disk, but now the database has been migrated to cloud storage. Like you can also take an example of like various e-commerce platforms. So some e-commerce platforms or some e-commerce companies which used to exist 20 years earlier and are existing now as well, so they might have some data. So it sounds very vague na, ki from 20 years they are using the same source for their data storage and everything. They might have migrated it to some different places. They might have opted some new techniques for data optimization and much more things. So basically, whenever we are doing this migration from hard disk to cloud storage, there is no effect which is seen in the logical level. So basically, whenever we are doing anything on the physical level, logical level is not affected, and that is called as physical data independence. So basically, any data change, or like any data change I can't say, but any thing which happens in the data, like the data storage has been removed from one place to another, or any change which is happening at a physical level won't affect the logical level. So this is called as physical data independence. Now the second one is logical data independence. So basically, in logical data independence, what it means, ki if any change is there in the logical level, it won't affect the view level. So basically, in logical level, what could be the changes? So basically, in physical level, we deal with where the data is stored, and in logical level, we basically deals with how the data is being stored, like in the form of tables, rows, column, how many columns are there, what are all are the constraints, and much more things we deal with. Consider that again, I am taking the same example. So I have a book database, right? Now in the book database, I have different factors such as book ID, book author. So right now I am taking these two columns into consideration. So I have ID and I have book author for this particular book database. Now consider I want to know more about like what are the types of books, like are there any thrillers, or are there any books which deals into drama, and much more things. So I want to know about the type of the book as well. So what I'll do, I'll add a new column, type. So basically what I did, I added a new column which is called as type. Okay. So since I have added a new column, there is some kind of change which is happening at logical level, but it won't affect the view level. How? So consider that earlier I wanted to see the ID and book. So I was doing a select ID, book author from book. Okay. And now again, if I this was before achieving logical independence, before achieving logical, and again after achieving logical, if I run the same query, I would be seeing the same data, right? So according to the user requirements, we are modifying the data, but consider that there are two users who are querying into the database, user 1 and user 2. So if user 1 is making any change, user 2 is not affected by this change. So that is basically ki whenever we are doing any changes in the logical level, like addition, modification or something, it's not affecting the view level at all. So this was all about physical data independence and logical data independence. I hope you got a slight idea about what is data independence. So I'm just reiterating everything. Data independence basically mean at any one of the level, if we are making any change, it does not affect the upper levels or the higher levels. Now there are two types of data independence. First one is physical data independence. Second one is logical data independence. In physical data independence, if we are making any changes to the storage or like where the data is residing, or like much more things are there, but again I'm taking the example of only storage of the data. So if we are storing the data at a particular place and we are moving the data to next place, it doesn't affect the logical level. And in the logical level, logical data independence, what happens ki if we are making any modification at the logical level, consider addition or modification of any columns or change in the any constraint, it won't affect the view level. So basically data independence helps us to ensure that at each level, if any change is happening, it is not affecting the others level. So in this particular video, we would be looking more on the essential components of table. So again, you would be saying ki why you are teaching us what is row, what is column. But again, there are some words for rows, some words for column, and much more things. So let's look at it, and then we will start with all the ER models and then the SQL queries and much more things. So basically the very first term is row or tuple. So basically the row, like in table, what we say is ki this is a table. Okay. So these are the columns. and these are the rows. But consider that someone asks you like what is the value or what are the elements present in this particular tuple. It might sound confusing na sometimes, because we generally remember these terms, rows and columns. We don't know what is tuple, we don't know what is attribute. So in like this particular definition, we are definitely gonna learn ki row is also called as tuple and column is also called as attribute in DBMS. So basically rows are known as records. See, we got a third name as well, right? So first is row, second is tuple, and third is records. So rows are also known as records or tuples, and it represent individual entries or instances of data within the tuple, within the table. So basically again, if we are inserting any individual entries for some particular columns, like consider name, consider class, consider roll number. So if we are giving some individual entries for everything, that is a row, like the place where we are giving individual entries in the table. So there is one more term which is kind of can be asked in your online assessment test of like 1 mark, or in your like semester exams as well, because like again people tend to forget the name like tuple for row and record. So there is one more thing which is cardinality. So basically what is cardinality na? The number of rows in a table is called as cardinality. Consider that this is my table. Okay. So this is the table I have. Consider it is a book table. Now someone asked me what is the cardinality of this table. So what I'll do is I'll count the number of rows. So this is R1, this is R2, this is R3, and this is R4. So all together the cardinality becomes 4. So cardinality is basically the number of rows in the tables. Now the second term is columns or attributes. Again, the column is a name which is a very generic name, so we tend to remember, but attribute is something we tend to forget. So column is also called as attribute. Column represent the attributes of the data being stored and are named to describe the information they hold. Consider like ID, name, and age. So basically columns are basically the attributes the table is having. Like consider that I am a person. I may have some attributes like I may have a ID, I may have a name, I may have a age, I may have a roll number, and much more things. So basically all the attributes of mine I can store it in table, in the column, in the tables. So basically column represent the attributes of the data which is being stored and are named to describe the information they hold. So consider that there is a table, consider, okay? So now I gave here Riti, okay? I should have make a bigger table. Okay. So this is a table, and here it is Riti, and here I have given 99372 ... Now, can you understand what is Riti and what is 99372 ... So basically what we do is na ki we give an attribute name. So basically this is a Riti, the name is Riti, and phone number is this thing. So basically whenever we define any attribute for all the entries which are feeded in the row, that is called as column. So again, as we read about cardinality in row, there is one thing which is called as degree, which is also the number of columns in a table. Okay, so T is a typo. So number of columns in a table is called as degree. So basically for this case, the number of columns are C1, C2, C3 and C4. So overall the degree becomes 4. So basically cardinality is the number of rows, degree is the number of columns, rows is also called as tuples or records, column is also called as attributes. So you can remember all these terms. Now coming to the next slide, this is a table which I have taken for reference. So basically you can see these are all the rows or tuples. These are all the columns and attributes. So iske bare mein to we got a clear understanding what is rows and what is columns. But what is this term primary key? Like what is this primary key? So primary key is something now which uniquely identifies the table. So let's look at it in the next slide. So basically keys are at number 2. but let's see with the constraint and then we will come to keys. So what are constraints? So constraint define rules or condition that must be satisfied by the data in the table. Common constraint which include uniqueness, nullability, default values and much more things. So consider I am making a table. Okay? In that table, there could be some fields which could be null. There could be some fields which couldn't be null. Consider that I am making a table about person and I am mentioning I am making Aadhaar card of a person. Okay? So in the Aadhaar card of person, I want name, I want the first name, I want the last name. Okay? But middle name is something which a person may have, may not have. So that column could be null as well. So we can set ki theek hai, this column can be null. But the first name and last name is something now which is required. So we have to mention ki that columns are not null. So we put a constraint that these columns are not null and this column can be null or something. So these constraints help us na ki even if I am feeding any data and if I forget to put the first name of a person and I just put on the last name, it will give me an error or it won't, it will show a error in the database itself. So consider this example which I told right now. So for Aadhaar card details, I have the first name, I have the last name and I have the middle name. So this is something which can have null values, but these both are something which cannot have null values. So these particular type of things, these particular type of checks whenever we put on in our database, that is called as constraint. It basically ensures ki we are not putting any kind of data in the database. There are some constraints which we need to follow whenever we are putting data into the database. So there are many constraints. First one is the unique constraint, which ensures the value in a column are unique across the table. So if there are values in a column, consider ID. So I need to take care that ID is something which should which should remain unique for all the entries which are there in the database. So for that case, unique constraint comes into picture. Now the second one is not null constraint. As I gave the example of this Aadhaar card, ki first name and last name couldn't be null, so we put a not null constraint. Now the third one is check constraint, which enforces a condition to be true for each row. So there would be a check constraint that consider there is a person and for them voter ID can only be made when they are above 18 years. So there would be a check on the birth date that check if the birth date is above 18 years, then only we can make the voter ID of a person, otherwise we cannot. And the fourth and final one is default constraint. So it provides a default value for a column if no value is specified. For this, what example I can give you? Okay, so consider that. Okay, consider you are in nursery class. Okay. So you might have a name, you might have some date of birth, and you might have a section. Okay? And consider in your school there is only one section, that is nursery A. So what it will do, it will feed the name, it will feed the date of birth, but when it comes to the section, there is only one section A. So what we do is we make default as A. So if I somehow left this particular field which is not filled, so basically it will take the default value and it is feed it as A. So default value is what it ensures that if the column is not having any values, they would be having a default value as this. So these all terms are you can understand from the very first thing. First name of this, unique, so something very unique. Not null, so something shouldn't be null. Check, so there is a check on true or false, or if there is a condition and we are checking it on the basis of that. Default constraint, something default we are putting a value. So from the very first letter you can understand the meaning of all these terms. Now the very last is keys, which I showed you here as well, this primary key. Now what keys help us in? So key, what basically it does now, it ensures that there is uniqueness in our table. So basically a primary key is a unique identifier for each record is also called as row. So each record in the table, it ensures that each row can be uniquely identified and accessed within the table. So what does this mean? So consider I am having a table. Okay. Now I am having a table as name. I am having the table name. Okay, just let me make a big table now. So I'm just making a more big table. Okay, so this is name, this is consider address, and this is consider phone number. Okay, consider there are twins, okay, and both of them have the same names. So consider that I and my twin both are having the same name as Riti, and we both live at the same place, that is Bangalore, and the phone number is also same for both of us. Now since we are twins, I know we might have same name, we might have same address, we might have same phone number, but there would be something unique between us na, matlab there would be something unique ki this particular person is considered having a roll number 1, I am having a roll number 2, or there should be something unique which could like at least identify my entire entries in that particular table, like it is for Riti 1 or it is for Riti 2. So basically what primary key does na, ki consider if I add a new column called as ID, and here I give ID 1, ID 2. Now whenever I need to see data for Riti 1, but I am considering twins, but I am saying like whenever I need to see data for Riti 1, I'll just make a query based on ID. It will give me all the required data. Whenever I need details about Riti 2, I'll make the query based on the ID, and it will give me the entire data for Riti 2. So there might be a possibility na ki many rows may have same data. ठीक है, मतलब consider you are having the same address and your sister is also having the same address, you are having the phone number of your father and your sister is also giving your sister or your brother is also giving the phone number of your father. So there might be a possibility that there could be same data which exists in the database. So for that thing, primary key is introduced, which uniquely identifies all the records or all the rows in the table. So it is basically kind of a unique identifier which uniquely identifies all the rows for a particular person or all the records for a particular person. Again, there are two keys, primary key and foreign key. Again, I'm not discussing in much depth about all like these keys. I'm just discussing about these terms because these terms would be used more and more from now, and you should be having a proper idea if I'm saying that it is a record. So you should be able to understand, okay, record is something which is called as a row, or if I'm saying tuple, then you should also understand, okay, it is a row or attribute column. So you should be having that proper understanding. Now, the second key is a foreign key. So a foreign key is a field in a table that refers to the primary key of another table. It establishes the relationships between two tables. Now consider that there are two tables, okay, and both tables have somehow data about me only. First table is having data about my name, my age, my roll number, and second table is having like details about my phone number and my address. Okay? So there are two tables which are having same data about me. What if there is one particular field ID which is there in table 1 as well and table 2 as well. So if there is a ID section in table 1 and table 2 which is kind of having similar data, we called it as foreign key. So foreign key is basically a field in a table that refers to the primary key of another table. It establishes relationships between tables. So basically it helps us to establish relationship between two different tables. So when we will be going in the query part and the SQL query part, or in the ER model itself, when we would be proceeding ahead, I'll be explaining about all these keys in very much depth, but it's just that for you to have a reference so that you don't miss out the next videos. So this was all about this video. I hope you like this video. This was a very beginner friendly video. So I hope you don't curse me for this, but again guys, see, I'm trying to like cover each and everything because it should be something which should be beginner friendly. Everyone would be able to understand the simple terms as well, right? I've seen my friends who are like very good at DBMS, but if they were asked in the interviews like tell me what tuples are there, the cardinality or the degree, they weren't able to say that, and it is a very minor concept now. So it throws an image on the interviewer that the person hasn't read it very well. So view is a virtual table that is derived from one or more underlying tables. This means that it doesn't physically store data but rather provides a logical representation of data. So from the definition, it is evident that view is something, it's not a table which is already created. It's kind of a virtual table. So if I need some data about like ID, a student ID, student name and student roll number, and I have a database in which there is student ID, student name, student roll number, student subject and much more things. So I can just create a view and I can just get all the data which is necessary to me. So basically views is also called as virtual table. Like the table is not created in the memory, but we get all the details through this virtual table. So in views, what happens now? We see the table according to the user requirements. Now consider I am having a e-commerce website. Consider a shopping website, okay? So let's just feed some data here. So ID is 1, name is Rahul. Phone number is consider XYZ, address is Bangalore, PIN is again I am giving some random values 192 and age is 18. Now here also I am giving some data, here also I am giving some data. Okay, so basically I have this database which is called as customer database. So I am having a customer database. As I am running an e-commerce website, there would be a database in which all the things would be stored. So consider that there is one customer, customer 1. It places an order in my website. Now what it will do is it will generate some ID for that particular customer. It will feed the name, the phone number, the address, the PIN and the age of that particular customer. Now consider that there are many teams in this shopping website. One is the team which is logistic team. One is a team which basically looks on the marketing and different other teams. Okay, so consider there is one person from the marketing team, name Ajay, and there is one person from the logistic team, name Vijay. Okay, just a rhyming word. So basically Ajay is a person who is majorly focused on the marketing of the website and the shopping website, and Vijay is a person who looks on all the logistics like the order delivery, if the order is placed correctly or not, if the order has reached particular person or not. So there are two persons. Now consider that Ajay want to see some details about the customer. Now Ajay is a person who is from marketing. So does it make sense that I send the age of the person, or I send the PIN of the person, or I send him the address of the person? I am creating a table, he's making a query in the table. So does it make sense that all these three fields are something which would be something concerning to him? It won't. There would be another field, consider, just give me a second. Okay, yeah, actually there's no space. Okay, just forgive my bad handwriting. Consider there is one more column in the table, that is order. So consider that this person orders some top, this person orders some tea, and this person orders skirt. So Ajay, basically from the marketing team now, he would be more concerned about how I can raise the marketing, how I can raise the sales. So what I'll do, if a person is someone who orders tea most of the time, I'll show him most of the ads regarding the tea. I'll filter his search, and there are much more things which I can do to increase the marketing. But again, am I considered about the age of the person? Am I considered, somehow age is also considered, but am I considered about the PIN of the person? Am I considered about the address of the person? Or am I considered about the phone of a person, phone number of a person? No, I am not. So basically I'm from marketing team. I just want what type of order this person makes, and age to some extent, because I can see, I can filter some of the items for a person who is above 18, some of the items for a person who is less than 18. So mostly I am concerned on that particular factors. So what I'll do, I'll make a query in the table and it will show me two columns only. First one would be it's two columns only. So first one would be the order, and the second age. So basically order and age is something which I am mostly concerned about. Now consider Vijay is a person who is from the logistic team. Now the logistic only needs to know what is your name and what is your address along with PIN and everything. But if a person is from logistic, is he concerned more about your age? What would he do after knowing your age, right? It doesn't make any sense to him to know your age, right? He is more concerned about like what type of orders you have placed, what is the address of yours, what is the pin code of yours, so that the order could be delivered at time. But he's not he's not very much bothered about your age and much more factors. So views and virtual table, what it does now, it shows me the fields, it shows me the table according to the user requirements. So if one person is from marketing, one person is from logistics, so in the marketing person will see all the fields which is concerned to him. The logistic person will see all the fields which is concerned to him. But it's kind of a virtual table. A new table is not created from the existing table. It creates a virtual table which shows me all those data, but the database remains unaffected. So basically this is view. So view, basically views or virtual tables is something which shows us all the required details according to the user requirements. So this is a small very small concept in DBMS, but people tends to get confused on this views in DBMS. So again reiterating the same thing. Views or virtual table is basically the logical representation of data where we see data according to the user requirements. If a user is from some particular team like marketing team, he would be only more considerate about the data which deals with marketing like orders, then the age and much more things. And if a person who is from logistic team is more concerned about the address, pin code and much more things. So basically keys in DBMS make sure of data integrity, uniqueness and quick retrieval of information. Key is an attribute in a table. So let's understand from an example. So consider that this is a table which is a student table. Okay. Now in this particular table, let's have some rows and let's have some columns. So I am having 3 rows and 4 columns. So let's just name them. Let's name it as ID. Let's name it as name. Then let's give it as registration number. And let's provide this as address. Okay. Okay. So like if you remember in the earlier videos, I told you that the rows and columns in the particular table is also known as, like the rows is also known as tuples or records, and the columns are also known as attributes. Okay. So basically what is happening here is that we have taken a student table. In that particular table there are some of the attributes or some of the columns which are like ID, name, registration number and address. So let's fill in some data here. 1 2 2 1 2 3. Name, let's consider just a random example, A, E, A, and here address I am taking it as XYZ. Okay. So what is happening here is that there is 3 entries or 3 records which is present in this particular table. Now what is key? Key is an attribute in a table. So this is a student table, right? So in this student table, what are the attributes? Let's list that down. So first attribute is ID. Second attribute is name. Third attribute is registration number. And fourth attribute is address. So basically these all are keys. So key is basically an attribute in a table. Now there is one more thing what we have seen here in the definition is keys in DBMS make sure of data integrity, uniqueness and the quick retrieval of information. So how keys are playing role? So consider that I want like all the details of a person whose ID number is 1. So if I make a query in the database with give me the person whose ID is 1. So if I'm making that particular query, what will happen? I'll get all the details of that particular person or that particular student which is present in the database. So it will help me for a quick retrieval of data, because again I don't need to provide whose ID is 1, whose name is this, whose address is this. So all these attributes or all these properties I don't need to define. I can just get the data with a single property. So keys always help in quick retrieval of information. Now coming to the uniqueness part. So in the further slides you will see about candidate key and primary key. So what is uniqueness? Now consider taking this example only. Here you can say the person who is having ID 1 is also having name as A. The person who is having ID 3 is also having name as A. So there could be a possibility that two persons can have same name, right? Or two students can have same name. So if two students are having same name, and if you're making query based on name, which data it will show? It can show any data, right? But you want a data of student whose ID is 1. So if you make a query with the use of name that give me the particular details about a person whose name is A, so you might get this particular data as well, or you might get this particular data as well, right? So but to get a concise data, to maintain the uniqueness in the table, there is a concept called as primary key which comes into picture, which we will be seeing in the further slides. But just to make you understand, ID is something which would be unique. Okay, so student A is having an ID 1, student B is having ID 2, and student A, the name is A, is again having an ID 3. So ID is something which is not duplicated, or there is not duplicate data which is present in the database. So ID is something which is always generated whenever a student record is being fed, or ID is something which would remain unique for all the students. So ID is something which is helping us to maintain the uniqueness in the table or the database. So and data integrity. So data integrity is something like if you have some integrity constants which are present, like consider that ID is something which is giving me uniqueness or providing me uniqueness in the table. What if I put an ID as null? So there are some constraints we put that this particular field can't be null, this particular field should be unique, this particular field should not be null, or this particular field should be null. So there are some unique constraints we put, on the basis of which we can always feed the data in the database. So if consider that I am making this particular attribute ID as not null, so I can never leave that ID. If I leave that ID and fill in the data, or create a query to insert the data, it will always throw an error. So there are some constraints which are being introduced to maintain the data consistency, data integrity, and much more things. So keys are helpful in maintaining the data integrity, then the uniqueness, and then the quick retrieval of data. Now let's jump into type of keys. So basically here I have listed down 4 types of keys. First one is candidate, second one is primary key, third one is foreign key, and fourth one is super key. So let's have a quick look through on all these keys and understand it with an example. So now the very first key is the candidate key. So you often have heard this term primary key in many prior videos of mine, but you haven't have heard this term of candidate key. So let's understand what candidate key basically means and how it is helping us in what is the proper significance of candidate key. So basically a candidate key refers to a group of attributes that are capable of uniquely identifying record within a table. Among these, one is selected to serve as a primary key. For example, consider for student all the possible attributes for candidate key could be student, this is a table where ID is a attribute, roll number is an attribute, Aadhaar card is an attribute. So let's understand from an example itself. So there is already a table which is present. Let me just create one more. Okay. So again we are jumping back to the same example which we have seen in the last slide. So there is a table student which is having ID, name, registration number, and address. Okay. This is the same example which we used in the last slide. So right now I am not filling much data I'm just giving again some random values, and here let's keep it as okay. So I have just put on some random values in this particular table. Now this is the table. So let's list down this table entities. So student is the table. The attribute of students are, student table is ID, then the name, then the registration number, and then the address. Okay. So these all are the attributes of the student table. Now in this attributes, there are some of the attributes, as I told in the earlier slide, ki ID is something which uniquely identifies records in the table. So there might be some of the attributes which would help us for a uniqueness, to maintain a uniqueness in the database. If that particular key is or that particular attribute is present, if I make a query in the database using that particular attribute, like suggest if I'm making a query in the database using ID, where the person ID is this, or if I'm making a query in the database using a registration number, the person registration number is this, so it will provide me a uniqueness. It will uniquely identify all the records. All the records means all the records which are present for student. Consider there are 3 records which are present for student. So there is an attribute using which if I make a query in the database, it will uniquely identify all the records in the table. So basically, what is candidate key? Candidate key basically refers to a group of attributes which are like, which uniquely identifies records in a table and which can be served as a primary key or a possible option for being a primary key in the table. So here I have listed down all the attributes. Now see, name is something, again there could be duplicate names. There could be like, there could be 2 person with the name Rahul, or there could be 2 person with the name Raj as well, right? So name is not something which can uniquely identify records in table, because again 2 person can have the same name. Now coming to the third thing is registration number. Now registration number is something which is generated at the time of admission. So every person who is taking admission would be having a unique registration number. So registration number is something which could help me to uniquely identify all the records or all the rows or all the details which are present in my table. So registration number is a possible option for a candidate key. Now coming to address. Now address is also something like 2 people can have, like address is also a attribute which have like lots of things, like the street, like the pin code, the area, and much more things. So area is something which could be like similar for 2 person. Street could be something which could be similar for 2 person. Obviously house number is not something which could be similar, but again area is something, street is something. Like address is something which is further divided into many subsections, right? So for now I'm not considering address as a possible option for candidate key, but again address could be, but again it's like you have to feed the entire address for that particular person, like one person who lives in street A, house number this, area this, and state this with pin code this, right? So here there could be 2 possible options. First one is ID and second one is registration number. So ID and registration number is something which could help me to uniquely identify records in the table. Let's not make it address, let's make it street. Okay, I guess now some doubts are clear. So I thought address was something which was confusing. Now street. So street is also something which could be same for 2 persons. So I can't make that street as a possible option for a candidate key or a group of attribute which can uniquely identify records in the table. So here we have possible options as ID and registration number. So for me the candidate keys are ID and registration number. Explaining in one word, candidate keys are the group of attributes which are possibly helping us to uniquely identify records in a table, and again in that collection we choose a primary key from that particular collection only for our table. So this is candidate key. Now the second key is primary key. Okay, so primary key is like most important. It would be used many places, at many places. It might have been used in the earlier videos as well. So understand it very clearly. I guess candidate key, if you have understand, primary key is very easy to understand. But let's just have a look at what is primary key and then let's understand it from an example. So primary key is a key which uniquely identifies records in a table. Again, there were some keys which we find out. First one was ID, second one was registration number, which was helping me to uniquely identify record in a student table, right? Now, it ensures that each tuple or record can be uniquely identified within the table. Now, this line is very important. So, it is always unique plus not null. So, primary key is something which would always have a constraint of unique plus not null. As again I explained in the earlier slides. Key, if consider that I am making ID as a primary key in this particular table, okay? So ID is a primary key. Now I am feeding the record for all the particular, for all the students which is present in my like task list or wherever Excel sheet. So I am feeding all the records of that particular student. Consider that while feeding, I left ID for a student, like by mistake, I didn't fill the ID. So it will throw me an error because again I am saying that ID is something which is serving as a primary key. So it should always be not null and it should always be unique. What does unique means? Unique means none of the two person can have the same ID, and not null means that particular field can't be left or that particular field needs some value. So basically starting from keys are something which like attribute of a table. So keys are basically attribute. Now coming to the candidate key. So candidate key is a group of attributes which uniquely identify records in a table. Now coming to primary key. So primary key is a key from all these group of attributes. Now from all these group of attributes, there are attributes like ID. Consider that there is an attribute called as phone number. There is an attribute called as Aadhaar card. Let me just type it. So consider that there is a student table. So since student is a like vast table, it would be having many information like student ID, student name, student subject, student fee details, student phone number, student address, and much more things. So right now I'm just considering few of the things. So consider the student table has ID, Aadhaar card number, phone number, and registration number. Okay. So these are all the group of attributes which are possible or which are an option for candidate key. Now consider like start from ID or start from Aadhaar number. So basically ID would always be unique and there is no place that ID could be left null, right? So ID is a good possible option to be a primary key, right? Now consider Aadhaar number. Nowadays, the government of India has made it mandatory to have an Aadhaar card for everyone. But there could be a possibility that one of the student doesn't have an Aadhaar number or one of a student doesn't have any PAN number. Like let's consider PAN number as well. So there could be a possibility that one student has a PAN number, one student doesn't have a PAN number, right? So it is somehow violating this fact that it should be unique and it should be not null. I can't make the PAN card number field as not null because many students can have PAN card, many students can't have PAN card, right? So PAN card or Aadhaar card is something can't be right now considered a possible option for primary key. Yes, they qualify for being a candidate key, but again for primary key they doesn't qualify because there is always a constraint which is there, that is unique plus not null. Now coming to phone number. Consider that a parent has two children and both of children are going in school for studying. Both of them are in the same class and then again they are giving the phone number. Now their father's phone number would always be same, right? So two fields would have same value. Again it is somehow violating the unique plus not null constraint, right? So it cannot be a possible option for primary key. Now coming to registration number. As I told that registration number is something which is generated at the time of admission, right? So every student would be having a unique registration number. So registration number is something which can qualify for a primary key. So either of them can be a primary key, right? So basically coming from keys is keys is basically attributes of the table. candidate key is basically group of attributes which uniquely identifies records in a table, and primary key is a key which uniquely identifies records in a table having the constraints such as unique plus not null. So if a attribute or if a key has a constraint which is unique, which is not null, it is a primary key. So now the third key is foreign key. So what is a foreign key? A foreign key is a field in a table that refers to the primary key in another table. It establishes a relationship between two tables. So what is foreign key? Foreign key is basically a key in another table which acts as a primary key in the prior table. So let's understand from example. Consider that there is two tables. First table is the student table, second table is the subject which the student has opted for. So the first table or the table which is being referenced is called as reference table or base table, or the table which is like kind of referencing from other table is called as referencing table. Now here the student table has the attributes such as roll number, name and hometown, and here the subject table is having attributes such as roll number, name and subject. Now can you see this roll number which is present here as well and here as well, right? So there is a roll number which is present in referencing table which is called as foreign key because it was a primary key in the base table. So basically a foreign key is a field in the table that refers to the primary key of the other table, and how it helps in establishing a relationship against student and subject. There are two tables and they have a relationship between them. Student studies a particular subject, like the student name is this and the subject he has opted is maths. So basically in student table and in the subject table there is a kind of relationship which is being established, and there in the relationship or in the referencing table, like there is a table from which we are taking a reference and we are making other tables. So basically from student table we can make like many tables, right? There would be many tables which would be referencing from the student table. Consider a subject table, consider a fee table, or consider other tables as well, right? So there will be many tables from that particular base table, and there would be some relationship of that base table with the referencing table, and in that referencing table the attribute which acts as a key is called as foreign key because it is being referenced from another table. So basically foreign key is a key which acts as a primary key in the reference table. So basically this is all about foreign key, a field in a table that refers to the primary key in another table. So basically what is happening, it is referencing this particular attribute. So here for this student table, roll number is the primary key, and for student table in the subject roll number is foreign key. So I don't want to extend the video very long. I guess it has been more than 20 minutes the video has gone to. So let's discuss more about foreign key, candidate key, primary key in the coming videos. We would be also discussing about super keys, and we will be solving many questions to understand in depth what is candidate key, how it is helping, how it is providing a possible option for primary key, and much more things. There are so many numericals as well. So I'll pick 2 or 3 and we will solve that numericals as well. So this was all about keys in DBMS. Just to give you a summary, key is an attribute. Key is like you can say that all the attributes which are present in a table can act as a key if they provide uniqueness, if they ensure data integrity, and if they ensure the quick retrieval of data. Now coming to candidate key is a group of attributes which could possibly be served as a primary key, or group of attributes which uniquely identifies record in a table. Now coming to primary key is a key which uniquely identifies record in a table, but there is a constraint that that particular key or that particular attribute which is be chosen as primary key should always be unique plus not null. And foreign key is a key which is basically acting as a primary key for another table. So basically these are all about the keys. So here we are seeing foreign key, but I want to re-revise the concepts of last as well. So basically what is key? Key is basically an attribute in a table. So any attribute in a table is called as key. Now what is attribute? So if there is a table, there would be some rows, there would be some columns. So basically all the columns is called as attributes, and all the rows are called as tuples in a table. So basically attributes. So key is any attribute in a table. Now what does keys help in? Key help us to maintain the uniqueness in the table. Key help us to maintain the data consistency in the table, and key also help us to get the faster retrieval of data. So basically keys helps in many ways. Now next we saw a concept called as candidate key. Now what is candidate key? Candidate. Now as I told na ki key might have three properties. First one is key, it ensures uniqueness. Second one is key, it ensures faster retrieval of data. And third is key, data consistency. Okay. Now in candidate key what happens na ki candidate key is basically a set of attributes which can uniquely identify records in a table. So what does that means is ki consider that there are attributes. Consider that this is student ID, this is a student table, there is a student ID, there is a name, there is a Aadhaar card, and there is a phone number. Okay. So now in this table, ID is something which would always be unique for every student, right? Like consider that there is one student. So for him the ID would be generated and it will always remain unique. Now for the next student also ID will always remain unique. Now for the next student also. So these all rows are also called as records. So for all the records the ID is something which remains unique. So it can be a candidate key. So it qualifies to be a candidate key. So in this candidate key, this candidate key is basically the set of attributes or the set of keys we can say, and here the ID is one of the key which help us to uniquely identify records in a table. Now the second one is name. Name is something like two persons can have the same name. So name is not something which can uniquely identify records in table. Consider that there is two persons who are having the name as Rahul, and consider that I am making a database query based on the name of a person. So consider I am making a query ki select star from table where name is equal to Rahul. Now which Rahul data it will give me? It can give me some inconsistent data, but I want the data of a Rahul whose ID is 1, whose Aadhaar card number is any 50040 something like that. Okay. So we are here providing some details, or we are here trying to fetch the details of a person whose ID is 1 and whose Aadhaar card details is given. So if I get the details of another Rahul, it is like the incorrect information which I am getting. So basically name is something which can remain same for different people. So name is not an attribute which would qualify to be a candidate key. So for name we would discard this. Now coming to Aadhaar card. Again Aadhaar card is something which is unique for all the people. So it will be unique for all the records in the table. Using the Aadhaar card, if you are making the query, we can fetch the details correctly and there would be a uniqueness. Like for if I am giving Aadhaar card number of a particular person, I would be only seeing data of one person, not two persons. So basically Aadhaar card helps us to uniquely identify all the records in the table. So Aadhaar card can also be a part of candidate key. Now the next one is phone number. Again phone number is something like it can be unique for every person or every person which is present in the record or every student which is present in the record. So phone number can also be a possibility to be a primary key. So here we can give phone number. So basically candidate key is a set of attributes which can qualify to be a primary key, or the set of attributes which uniquely identify records in table. Now coming to the third key, that was primary key. Now what is primary key? Primary key is a key which uniquely identifies all the records in the table. Now you would be saying ki candidate key also does the same. There is a set of keys which uniquely identifies all the records in the table. Then how come I can select a primary key? So basically primary key is being selected from all the set of attributes which is mentioned in the candidate key. So from all these three attributes, one can be primary key. Now let's see that which one can be a primary key. So now consider ID. Again ID is something which is generated whenever a student take an admission. So ID is something which won't be, okay, there is one more constraint for primary key, that any key which is having unique plus not null constraint can only be a primary key. So any key which is having unique value, also null value shouldn't be there, because again it can't uniquely identify the records in the table. So any key which is, or any attribute which is serving as unique or which is having the constraint as unique plus not null is only qualified to be a primary key. Now coming to ID. ID is something which is generated every time the student takes the admission. So basically ID is a good qualification for primary key. Now coming to Aadhaar card. There could be a possibility na ki few of the people don't have Aadhaar card number, like they haven't registered for the Aadhaar card yet. Few people have the Aadhaar card but few people don't have the Aadhaar card. So for them the Aadhaar card attribute or the Aadhaar card column would be null. And again what we told that primary key is something which is not null. So it won't be a good option for being a primary key in the table. Now coming to the phone number. Consider that there are two students and they both are siblings. Now they would be filling the details of their father phone number, and father phone number is something which could be same for two people as well, because 2 or 3 students could be there who are having the same father or they are siblings, right? So phone number is also not something which will uniquely identify, because there is a possibility of duplicacy, and again it will then destroy this unique constraint. So phone number is also not something which will qualify for a primary key. It can qualify for a candidate key but it won't qualify for a primary key. So at the last, ID is something which becomes our primary key. So in short, key is something which is attribute of a table. Candidate's key is a set of attributes which uniquely identify record in a table and which can also qualify to be a primary key. Primary key is a attribute which uniquely identifies record in a table. Also primary key is something which is unique and not null. So any attribute which is having unique plus not null constraint is only qualified to be a primary key. So this was all about candidate key, primary key and keys. Now we will look on foreign key. I'm just re-revising the concept because referential integrity is something which is related to foreign key, but just a revision because it is keys in DBMS. So basically foreign key. A foreign key is a field in a table that refers to the primary key in another table. So basically what is foreign key? Foreign key is an attribute or is a field in a table which refers to the primary key of another table. So what is happening? There is two tables, right? In one there is a foreign key, in one there is a primary key. The table, consider that there are two tables. I'm just drawing table A and table B. Now consider table A is a student table, okay? And table B is a table which have all the details about students, like the course they have taken or the subjects they are studying, okay? So here there would be some columns, here also I would say the word attributes. So here there would be some attributes, here also there would be some attributes. Consider that here the attribute is ID, name and hometown, consider, okay? And here the attributes are ID, subject ID and subject. Now what is foreign key? So foreign key is basically a field in a table which refers to the primary key of another table. So basically in table A the primary key is ID. In table B, right now I'm not more focused on primary key, I'm more focused on foreign key. So foreign key is ID because ID remains same here and remains same here. So what foreign key is doing now, foreign key is kind of establishing a relationship between two tables. So table A and table B have a relation. So table B is having a foreign key which is pointing to the primary key of table A. Student and course are two tables. Student is somehow related to or have a relationship with course. They have opted. So course is having a foreign key and the student table is having a primary key. Now student table which is being referenced is called as reference table, and subject table which is referencing other table is called as referencing table. So basically here table A is there, table B is there, okay? Now let's take an example. What if these two are separate table, table A and table B are separate table. What if the foreign key in this table is ID, but could the primary key be also ID? Is it a possibility कि foreign key and primary key is same for table B? So there could be a possibility that the foreign key and the primary key for table B is same, but again like there could be a chances of anything. So foreign key and primary key for table B can be same as well, can be different as well. So it totally depends. But again, foreign key is something which should be present in the table we are referencing to, right? So reference table or the base table, if it is having a primary key in the another table to establish a relationship, it should always have that primary key which is present in the form of foreign key. So basically what foreign key does now, foreign key maintains referential integrity, which is the video all about. So I guess it's almost 10 minutes and we are now jumping to the topic. Prior was all the revision about keys and everything. I hope everything is revised, because I really need you to understand keys in depth, and then we can jump ahead to referential integrity. So now coming to reference table and referencing table. So basically what is a reference table? Reference table is a table which is having primary key, PK, and referencing table is a table which is having a foreign key. So basically this table is having a foreign key which is basically pointing to the primary key of the base table. So this is called as referencing table and this is called as reference table. We would be using these terms all throughout this particular slides. So please be careful about what is reference table and what is referencing table. You can understand it in this way. Okay, reference table is something which is being referenced from another table. So table B is referencing to table A. So table B is a referencing table and table A is a table which is being referenced. So table A is a reference table or base table. Now what is referential integrity in foreign key? So basically referential integrity now, let's just break this term. So it is referential integrity. So what does integrity means? Integrity means na same thing everywhere. So let's understand referential integrity from an example. Consider that you are hungry right now, okay? So you have 2-3 options to order food. Either you can order it via Swiggy, either you can order it via Zomato, either you can order it via Uber Eats. Like there are many options for you to order the food, or either you can order it from Domino's, Cloud Kitchens and much more. Okay. Consider you want to have a pizza. So consider in Swiggy the price for the pizza is 154 rupees after discount. The price of pizza in Zomato is 152. And the price of pizza in Uber Eats is around 150. So you can see that there are differences in prices in all the 3 apps, Zomato, Uber Eats and Swiggy. So data is something now which is not consistent in all the apps. The prices for the food differs in all the app. So basically integrity is something which is not maintained here, because again it all depends on the apps and the companies, that how much profits they are making, how much margins they are keeping on and much more things, right? So integrity is something which says us that there should be same data which is present everywhere for a particular thing. Like for a particular pizza, there would be a same price which is present on all the different platforms. But somehow it is violating that thing, because for the same pizza at different platforms, the price is not same. So basically what happens in referential integrity is referential integrity is an important concept in foreign key. We always say foreign key maintains referential integrity. What is the reason behind we saying that foreign key maintains the referential integrity? So basically referential integrity ensures that the relationships between the table remains accurate, consistent and meaningful within a relational database. So referential integrity, what it says is, consider that right now I am a college student, okay? So I am a college student, Riti, who is currently in the computer science branch and who is having a roll number as 14, okay? So if someone asks me in the entire college, if someone asks any person, get me the details of Riti, who is right now in CSE branch and whose roll number is 14. So they would get the same data from everywhere. Like if they ask my data in the library, if they ask about my data in the admission corner, or if they ask about my data at other places as well. So the data remains the same. My name, my roll number, my ID, everything remains the same. There is no change in the data. So basically integrity is maintained here. So integrity means in any databases, if you are making any query, there is the same data which is present for a same person. So I guess referential integrity is something which is a bit confusing, but I've tried to break it into simpler terms and explain you. But again, in the coming videos, we would be looking on how referential integrity is being maintained in the databases, how foreign key is helping us to maintain the referential integrity. What if if consider that there are two tables and referential integrity is something which is maintained in both the tables. Now consider that in one table we are inserting something, in one table we are updating something, and they are somehow related with the primary key and foreign key relationship. So what would be the effect on the tables and much more things. So there are much more things we would be looking in the coming videos. Basically you can understand that foreign key is something which maintains a relationship between two tables, and there are some set of rules which make sure that the relationship between two tables which is maintained is accurate, consistent, and have a meaningful relation. So basically to ensure that thing, referential integrity comes into picture, and we have to see that what happens if we are inserting something, if we are deleting something, or if we are updating something from the reference table or the referencing table, how the referential integrity is taking place and what all violations of referential integrity could take place. Since there are two tables, consider there is a table student and there is a table course. Okay, so now consider in the student table we have some set of records and some set of attributes. In the course table as well we have some set of records and some set of attributes. Consider here we have a student roll number, then student name, and then student phone number, and here we have the course ID, the course name, the roll number, and the course details. So we have two tables, student table and the course table. They have some attributes such as roll number, name, and phone number, and here course ID, course name, roll number, and course details. For this the primary key is roll number, which will basically help us to uniquely identify all the records in the table or all the details about the particular student. And here the roll number is present and somehow student is related to course, like student is taking a course. So there is a relationship which is maintained, because consider now student, there is a huge database of student name, student phone, student address, student roll number, then what courses student has taken, then what fees student is paying, what is the attendance. So there is humongous data about student. So what we do is we split it into a tables. So basically this is a student table and this is having the details about all the courses student has taken. Now consider here I am giving some roll number 1, 2, 3, 4, and here also I am giving roll number 1, 2, 3, 4, and other fields right now I am leaving it as blank. So here basically roll number is the primary key. Now I want to establish a relationship between student and course. So what it will do is here it will mark this as foreign key. So what is a foreign key? Foreign key is basically a key which targets to the primary key present in another table. So basically it is somehow referring to the primary key in another table. So this is a foreign key. So basically a relationship is being established in this particular tables. So referential integrity help us to maintain this relationship. Referential integrity help us to maintain the data accuracy ki roll number 1 is here, so here also roll number 1 is here, the details are remaining the same, and data consistency. Again, if roll number 1 is somehow removed from here and here the roll number 1 is there, so data is inconsistent. So basically it helps us in these particular ways. Now the table which is being referenced is called as reference table or base table, and the table which is referencing to another table or which is pointing to the primary key of another table is called as referencing table. I think I should point the arrow like this. So basically this is a referencing table and this is a reference table. Now what if we insert some data in the reference table? What will happen to the referencing table? As this table is particularly not having much of importance without the student table. So what if in the student table we add some data? What if in the student table we update some data as well as delete some data? So what will happen in that particular cases? So we will be seeing case by case what happens and how we can ensure that these particular violations of rule, if happens, doesn't happen. So basically now consider there are two tables, one is referencing and other is reference table. So reference table, referencing table. Let's see how some operations like insert, update and delete works here. So referential integrity in foreign key, insertion in the referenced or the base table. So consider, again I am making the same drawing. I'll make it a bit quick. So basically this is a student table and this is the reference table. Okay, reference.base table. This is the course table. Now it is having field as course ID, course name and roll number, and this is also having fields like roll number, student name and student phone number. So I'm just filling 2 or 3 details. So 1, 2 and 3, student name Aman, Raj, Riti, and phone number 00010002032. Here CID, course ID I'm giving as 0102, course name DBMS, operating system, and roll number is 1 and 2. So now I have made a tables, and here it is a primary key roll number, and here the same roll number is called as foreign key, which is pointing to this. Now we are talking about what happens when there is an insertion in the reference or base table. Consider that a new person or a new student takes admission another day. So I'll register his data or fill his data. His name is his roll number is 4. His name is consider Radha, and her phone number is 022. Now if this insertion take place of roll number 4 Radha, does it affect this particular table? Think. No, it doesn't affect. So because student table or student database is a database now which keeps on increasing. Every year some new student take admission. In between the sessions also some new student take admissions. So right now in the course table I am having details about the students who have already taken admission and have already been assigned some courses. But since this particular student has taken admission newly, maybe he or she haven't been assigned any course yet. So if there is insertion here, it doesn't violate any of the rules or it doesn't affect this particular table, because this particular table is having details of student with roll number 1 and 2. So roll number 3, roll number 4, or even if there are some more roll number 18 or 90 tak bhi, if there is some insertion, it won't affect the table. So basically if there is any insertion in the reference table, it won't be affecting the referencing table. Now the second one is deletion in the reference or the base table. So I guess it is a tedious task here to make table each and every time. So again I'll make it a bit quick. So this is a course table with CID, course name and course detail, roll number. And this is a student table with roll number, name and phone number. So this is basically the referenced or the base table, and this is the referencing table. So it is having 1 2 3 1 2 3 and 0 1 0 2 0 3, and here 1 2 3, course name DBMS, just making it very fast, and name consider R E F. Okay. So basically there is a person R, there is a person E, and there is a person F. So what happens if there is a deletion in the base table or the reference table? Consider roll number 3. He or she has passed out from the particular school or college, or consider that he or she had her father or his father had a transfer and now she need to leave the school in the middle of the session. So what happens when there is a deletion from the reference or the base table? Would it cause this particular table? Yes, it will. Why? Because see, here for roll number 3 we have entered all the details. Ki roll number 3 is having a course name, is being assigned a course, basically operating system, and is having a course ID 03. So basically if we are removing the roll number 3 all the details from the base or reference table, the referencing table doesn't make sense, which it will be pointing to. So basically here the foreign key is pointing to the primary key of this particular table, and if we are deleting any data here, so where it will point to? So basically it will consider I want the details for roll number 3. So this particular field will not give me any details, because it is only saying roll number 3 is having course name as this, course ID as this, but the student is not yet in the school. So if the student is not in the school, does this data make sense? No. So basically, whenever there is a deletion in the reference table, we need to move it from the referencing table as well. We need to remove the data from the referencing table. So basically, if any student has dropped out from the college or from the school, there all the details, all the data which is present needs to be deleted. So it may cause violation if the corresponding data is present in the referencing table. So basically, if the corresponding data which is removed from the reference table and is still present in the referencing table may cause some problem and may cause some violations. So to make sure that if some data is deleted from the reference table, it's not present in the referencing table, there are some methods and some tricks we can use. So let's have a look. So if a record in reference table is deleted or updated, the corresponding records in the referencing table should also be deleted or updated to maintain the integrity of the relationship. Basically, integrity means data consistency, data relationship, data accuracy. So what we can do is we can use actions like cascade delete for the same. Also, we can set null for the values deleted. So what it will do now, cascade delete, what it will do, if some data which is being deleted from the reference table, what it will do, it will delete it from all the referencing tables. So basically, if a person who is named Ram has dropped out from the college or from the school, if we delete his data from the student database, what it will do, all the other tables which are referencing to student database, they will cascade delete will delete all the data which is present in the other tables as well. So basically, cascade delete is a method which we can use to ensure the integrity is maintained. Or what we can do is we can set the values as null for that particular student whose record has been deleted. But again, there is a twist. Consider that in the referenced table, if a record is deleted and we set the value null in the referencing table, like consider null, null, null. What if this course ID is a primary key and we are setting the value as null here? So primary key can't be null, right? So this null method is something which is not very much used, or which I also won't suggest to be used, because again, if you set all the values as null, what if any of the attribute is a primary key? So primary key can't be null, right? So you can use this cascade delete, which would really help to delete all the data which is present in all the referencing tables. Now the third and the last operation which is left is update. So updation in the referenced or the base table may cause violation, because if the corresponding data is present in the referencing table. So consider again we are having two tables. One is the referenced table and one is the referencing table. Now I'm just filling the data only for one field because it's an update operation, so I can explain with a one field only. Consider there is a roll number, student name, student phone number and student address, and here it is course ID, course name and course roll number. So consider roll number is 1, 2, student name is Ram, Raj, phone number is something, address is something, okay? Consider 012, 013, address is ABC, XYZ, and here the course ID is 011, 012, 013, course name is DBMS, OSCN, and the roll number is 1, 2 and 3. So consider that there is an update in the data. What happens if there is a person with roll number 3 named Riti, 014 and ZZZ. Okay, so what happens if roll number 2, which is Raj, has dropped out from the college or dropped out from the school? So what happens his data is deleted from here as well and there as well. What if Riti data, like now Riti is roll number, priorly Riti was roll number 3, but now Riti has been changed to roll number 2 as roll number 2 has left the school. So there is an update in the roll number, right? consider that there is more update in the student name as well. Like sometimes student give their half name or the first name only, but according to Aadhaar card or according to the board mark sheet, they should be giving their full name or something like this. So consider that there is any update in the data which is happening at the reference table. So would it affect the referencing table? Yes, it would affect, because if we are updating the data here, the data should be updated everywhere. Ki roll number 3 is now having computer networks and having the course ID is 013. So roll number 2 data has been deleted. So basically, just like delete, in update as well, there is a command called as cascade update, which will update all the details for the particular person you are updating in the reference table. So basically, for insertion, there is no violation. For deletion and updation, there is a violation. So we should be using on cascade delete, on cascade update to update in the all the referencing tables and delete it from all the referencing tables. What is a reference table and what is a referencing table? Referenced table and referencing table. So like you can understand it in a way na ki reference table is also called as base table. Basically, reference table is a table now which is being referenced. Like consider that I have made a table. It is taking reference from one table. So that particular table from which it is taking the reference is called as reference table. So basically, you can think in a way that the table which is having primary key is called as the reference table. Now the referencing table, the table itself which is taking reference from another table is called as referencing table. So here you can consider the table which is having a foreign key is called as a referencing table. So basically this was referenced and this was referencing table. Now in the last video we got to know ki what happens whenever there is a insertion, deletion or updation which is happening in the reference table. Now why we need to know this operations and what happens, like how all these things are related. So basically what happens na ki whenever there is two tables, there is one table which is having a primary key and there is another table which is having a foreign key, which basically establishes a relationship between two tables. Now why this relationship between two tables is needed? So consider there is a student database, right? Now student database is such a huge database. If we consider कि there is student name, student roll number, student ID, student address, student subjects, there are much more things, right? So there would be some multiple tables in which there would be student information stored. There would be some tables which basically depends on student itself. So consider that a student has taken admission into the school or college. Now the student may opt some subjects, may pay some fees, may be a part of some club or different things. So club, and like if the student takes the admission, only then he or she can be a part of club. If a student takes admission, only then he or she can take a subject. So basically subject is a table which is called as a referencing table, which basically takes reference from the reference table. So consider here the reference table is a student table and here the referencing table is the club they are a part of. So basically referencing table is mostly dependent on the reference table. Referencing table has all the data which reference table, like basically in the reference table all the data which is present. In the referencing table you will get all the reference data for that particular person or for that particular student. So for that particular student, what is the club in which he or she is, what is the subject he or she has taken. So there could be multiple referencing tables for one reference table. So there is a relationship between reference table and referencing table. Now what happens whenever there is some CRUD operations which is being performed on the reference table and referencing table. So for the reference table, as I told you ki whenever there is an insertion, deletion or updation, there are some violations or there are some rules which is broken in some cases. So what are these rules and why broken and violation means so much to us? So basically what happens na ki let's start from the very beginning. So there is a reference table. Now there are some sub tables which acquire data from that particular table or that particular database. So there is a reference table called as student. Let's take it. So there is a reference table called as student. Now student is having so many referencing tables, like the club which student is a part of, subject, co-curricular details and much more. So basically this is a referenced table which is having a primary key And then these are the referencing tables, which is having a foreign key. Now these two tables may have a relationship between them. Now there is a term called as referential integrity. What does this term means? So basically referential integrity means, integrity means ki same data in all the databases. So what does this same data in all the database means? So consider that there is a student Raj. Okay, so Raj is currently a CSE student or an IT student. Now in the college, whenever you will go to any of the cells of the college, like the placement cell, the admission cell, the library, the physics lab, the chemistry lab, everywhere, you will find Raj with roll number this and having a subject as CSE or having the branch as CSE. You won't find any data of Raj where Raj is studying in electronics who is having the same roll number. So basically in all the places, in all the databases, the data would remain the same. So basically integrity means same data everywhere. So referential integrity are some set of rules which ensure that the relationship between two tables have the data accuracy, have the data consistency, and have the faster retrieval of data. So referential integrity are some set of rules. Now these set of rules may violate whenever you are doing any kind of insertion, deletion, or updation in any of these tables. So basically we discussed in the last video about the reference table, ki what happens whenever there is an insertion, updation, or deletion in the reference table. Basically in this particular video we would be mostly focusing on the referencing tables. So it was just a recap for what we have learned in the last video. I thought to give you that because if someone is new to this video, won't understand what is the term referencing table, reference table, and foreign key, primary key, referential integrity, and much more. So let's start. So basically the first is insertion in the referencing table. So now let's make two tables. First one is a student table and second one is the subject student has taken. Okay, so here I am giving student a roll number, student a name, and consider student a phone number. Okay, and here I am giving student a subject ID, subject name, and here the roll number. So basically 1, 2, 3. There could be many more students. First is Raj, Riti, Rahul, and phone number is considered 0012 0019 000674. And here I am giving as ID as 01, 02, 03, subject name as physics, chemistry, maths, and roll number as 1, 2, and 3. So basically we have two tables here. First one is the student table and second one is the subject table. Now in coming to the student table, so student table has a field called as roll number. So roll number is an attribute which can uniquely identify all the records in a table. If I just make a query with the roll number, give me all the details of a person whose roll number start with 2 or who is having a roll number 3, it will give me all the details for that particular person. So roll number is a primary key for us. So basically an attribute which identifies all the records in a table uniquely. So basically this is a primary key. Now since these two tables have a relationship between them, so to establish that relationship there should be an attribute which is present in this particular table which should be present in another table. So basically here this attribute is roll number, which is called as foreign key, and it points to this. So what is foreign key? Foreign key is basically a key, or you can say collection of keys or collection of columns, which basically refers to the primary key in another table. So basically this foreign key is referencing to the primary key in another table. They are having a relationship between them. Now the referential integrity comes into picture, which establishes some rules which should be there to maintain the data accuracy, to ensure that there is no data inconsistency and faster retrieval of data. Now in this particular table, first thing is insertion in the referencing table. Consider, so let me just give the name. It is a referenced table and this is a referencing table. So the first is insertion in the referencing table. Consider that I want to insert some details in the referencing table. Consider SID is 4, subject is biology, and roll number is 4. So would it cause any violation, or what would happen? So see, now what is happening is we are inserting a particular row in the referencing table. Now what will happen is we have inserted this particular row in the referencing table, but do any student present in the student table whose roll number is 4? Is there any student who is having a roll number 4 and is present in the student table? There could be a possibility, there couldn't be a possibility, right? So this insertion may cause violation because we are not sure that roll number 4 exists in the student table or not, and somehow this subject table is taking a reference from the student table. So if this roll number 4 does not exist in the student table, it doesn't make any sense to add it in the subject table. So in the subject table we had added key a person who is having roll number 4 is having the subject name as bio and is having the subject ID as 04, but there isn't any student who is having a roll number 4 exist in the student table. So basically insertion may cause violation. Why I am saying may cause violation? Because consider now there could be a possibility that roll number 1 is taking 2 subjects, physics or chemistry. So I can insert data for roll number 1 twice or thrice or 4 or 5 times. So basically it's not important ki insertion will always cause a violation, but it may or may not cause in the case ki whenever there is a roll number which is present in the student table, and for that roll number I am making an entry in the referencing table, but it may cause violation whenever there is an insertion for an entry which is not present in the student table. Now coming to the second one, that is deletion in the referencing table. So let me just quickly draw. This is subject. So this is roll number, this is student name, and this is phone number. Now this is to subject ID, subject name, and then this is roll number. So I'll just quickly give the datas. 1 2 0 1 0 2, subject name physics, biology, name Rahul, Raj, Riti. Actually these three are the common name I use, and 0012 0013 0014. Now again this is the primary key, this is the foreign key, and it is taking reference from the primary key. Now what happens ki what if there is a deletion in the referencing table? So basically this is the referencing table and this is the reference table. So consider today I have deleted the data for roll number 2. So I have deleted ki there is a roll number 2 which existed and has taken a subject biology. Would it cause any violation? Think. It won't. So why it won't cause any violation? Because see now, there are many roll numbers present in the student table. So there is roll number 1 who has taken a subject physics, roll number 2 who has taken a subject as bio. But what if roll number 2 doesn't want to take a subject bio? What if he or she gets promoted into next higher sections or higher classes and they don't want to take bio? So it will be deleted from the database of the referencing table. So does it cause any violation? No, right? Because see, after 10 you get an option ki bio or maths. So if I choose bio, why would I take maths? So I can delete this particular data from the database of referencing table. So basically it won't cause any violation whenever we are deleting anything from the referencing table, even if the data present in the reference table. So basically there might be a possibility that there is a student Raj with roll number 2 who is now not having bio as his additional subject or bio as his subject. Now he is opting for maths. Now the third and the last is the updation in the referencing table. So actually I'm drawing these tables because I want you guys to understand what is happening at the very depth. So let me just make it very quick. Student, subject, subject ID, subject name, roll number, student name, student phone number. So here 1 2 3, here also 1 2 0 1 0 2, subject physics, bio, name Rahul, Raj, Riti, and phone number 001 002 003, any random values. Now what happens ki whenever there is an updation in the referencing table? So basically this is the referencing table and this is the reference table. So whenever there is any update in the referencing table, what will happen? Think. So basically whenever there is an updation in the referencing table, now what happens? Consider that you want to update the student subject ID for that particular subject, physics. Till then it's okay. If you want to update the subject name, what if roll number 1 now wants to take maths instead of physics? It's again okay. But what if you want to update the roll number? So basically roll number is acting as a foreign key which is taking a reference from the primary key which is present in the student table. So if you update the roll number, consider you update the roll number to 10. But there is no roll number with 10 which exists in this reference table. So does it make a sense? No. So basically what updation does is if whenever you are updating any of the values, which is any of the values apart from the foreign key, it may not cause violation, but whenever you are updating the values which is acting as a foreign key in the referencing table, it may cause violation because foreign key is referencing to the primary key of the reference table, and whenever we are making any update in the foreign key, it may cause violation because the same details may not exist in the student table. So roll number 10, if we have updated this roll number from 1 to 10, there is no such student with roll number 10 which exists in the student table. So how it would take a reference? There would be some data inconsistency. So basically here we won't find any roll number 10, and here we will find the details for roll number 10 who has or who hasn't taken any admission yet. So basically all these things happen whenever we are doing any kind of CRUD operations in the referencing table. So what is integrity constraint? Now consider that there is already an existing database, and consider there is a scenario where we are creating a database. So in this existing database, there would be some kind of update we would be doing in our day-to-day life, or some kind of insertions we would be doing in our day-to-day life. Now for that insertion and for that updating the values of some particular fields or some particular attributes, there are some set of rules which needs to be applied before doing any kind of insertion or any kind of update in the database. Now why this set of rules is needed, or why it is so much important? Now consider that there is a student table. Okay, so there is a student table in which we have fields like student ID, student name, and just a second. Okay, let me again draw it. So basically we have a table of student in which we have 2 columns and some fields. First one is student ID, second is student name, and third is student age. Now consider that there are already some existing data present in this table. Now consider that there is a new student who has taken admission in the school. Now I am inserting values for that particular student. So I have inserted the student ID 03, the name is Ram, and consider I have given the age ABC by mistake. So if ABC is inserted here, now this is kind of an invalid or incorrect data because student age can't be ABC, right? So there are some set of rules we apply at that particular time कि student age is a field which will only take integer values. Or consider that again I am entering a new field or a new record, and here I am giving student ID as 04, the name as Priyanka, and now here the age I am giving as -5. Again, no one age could be -5, right? So there are some invalid data which could be entered if we don't ensure that there is an integrity constraint, or there are some set of rules which is applied. So basically integrity constraint come into picture whenever we are inserting any kind of data, or whenever we are updating any kind of data in our database. They make sure that there are some set of rules which is enforced so that we don't mention or don't apply or don't insert any kind of incorrect data or invalid data, and data consistency is maintained all throughout the databases. So basically there are various type of integrity constraint. So the first one is domain integrity constraint, the second is entity, the third one is referential integrity, fourth is key, fifth is check, sixth is null, seventh is unique, and eighth is default. So basically there are various type of integrity constraints, and we would be knowing in brief about all these integrating constraints in next slide. So the first one is domain integrity constraint. Now what is domain integrity constraint? See, domain is something na ki consider that you have a table, theek hai? In that particular table, there are some attributes which we usually call as columns and attributes in terms of DBMS. So there might be some columns or there might be some attributes, right? So for that particular attributes, we give some domain that, okay, if there is an attribute called as student name, it will only take character values. If there is an attribute called as student age, it will only take integer values. So basically what happens is, consider we have a table. There are two columns. There is a name and there is a age. So basically in age we give that it will have integer values. In name we give that it will have character values. In age also sometimes we make sure that age shouldn't be 0 because no one is having an age as 0. Age shouldn't be negative values. So basically for these particular things we add a check constraint. So what this check constraint does is ki check constraint makes sure that a particular condition is fulfilled, only then the data is inserted in our table. So basically we'll put a check ki check if the age is greater than or equal to 0 and less than or equal to if there is some criteria present there. If not, you can put that check if the age is greater than or equal to 0, only then insert the data. So basically for this particular name we are inserting character values. For this particular field or attribute age, we are inserting integer value. So basically domain constraint, it ensures that the validity and appropriateness of data values, that is valid data types, character or integer, ranges, check constraint ki it age is greater than or greater than 0, not equal to 0, ranges and formats for the column. So within a specific column or attribute of a table. So basically it ensures that the validity and appropriateness of data values within a specific column of a table or attribute. It basically ensures that the validity is there, the appropriateness is there, that the valid data types are going there, the valid ranges are going there, or the valid formats are going there. Now there is an example. Check for date column so that it contains only valid date values. So basically consider that there is a date field or date attribute which is present in the table, and in this date attribute someone writes ABC. Again, it makes no sense to give ABC in a date column. What does this mean? A date ABC, what does this mean? This means nothing, right? So there should be some checks which should be there for all the attributes. There should be some domain which should be given for all the attributes so that everything lies within that particular domain. There should be some range of values. There should be some domain of data type or some types of data types which should be there. Like there are many things which should be ensured in particular columns or the particular attributes of a table. So basically domain constraint make sure that these particular things are ensured. Now the second one is entity integrity constraint. So basically it ensures that each row or record in a table is uniquely identified by primary key. It also helps in preventing duplicate or null values in the primary key. So basically entity integrity constraint, it basically you can say that deals with the primary key. So what it makes sure is, it makes sure that each and every table have a primary key so that it can uniquely identify all the records in a table. Now what is primary key? Primary key is basically a attribute which is like unique plus not null. So any attribute which qualifies the unique constraint and the not null constraint is called as primary key. And entity integrity constraint makes sure that there is always a primary key which is present in the table. What primary key does is कि primary key help us to reduce all the duplicate values, maintain the data consistency throughout or within the table, and it also helps us to uniquely identify all the records in the table. So basically entity integrity constraint makes sure that there is always a primary key which is present in the table. So it ensures that each row or record in a table is uniquely identified by a primary key. Now the third one is referential integrity constraint. Now this constraint is basically dealing upon the foreign key. Now what is the foreign key concept? Foreign key is basically a key which references to the primary key of another table. Now what happens if there are two tables which are having a primary key and foreign key relationship? Consider that there are some insertions in one particular table and there is some deletion in one particular table. There shouldn't be any data inconsistency that should be there. So consider that there are two tables, one is having a primary key, another one is having a foreign key. So basically in that table which is having a foreign key, or the table which is the referencing table, if we add any value, right, if we add like we randomly insert any data in that particular table, so it will not reference to any particular student or any particular record which is present in the table A. So basically that particular data is an invalid data or an inconsistent data because it does not have any meaning. Let me just draw it and let you know. So basically there are two tables, table A and table B. These are having some attributes and these are also having some attributes. So basically there is a roll number, there is a course ID and course name, and basically this is a course table and this is a student table. So it is having student ID, roll number, student name. So basically roll number is acting as primary key here and roll number is acting as foreign key here, and foreign key is basically referencing to the primary key here. Now consider that there are roll number 1, 2 and 3. Here I am also giving roll number 1, 2 and 3. Now what if I add one more record in this particular table, roll number 4. Now this particular table, course table, is taking a reference from the student table, right? And now we have added a new particular record which is having a roll number 4, course ID as something and course name as something. So this particular roll number 4 does not exist in this student table now. So what it will reference to? Because consider that there are 3 people in a class. Now I have allotted a fourth person a particular course and a particular course ID, but the fourth person does not exist in the class. So does it make any sense? No, right? So basically there is data inconsistency which is there. So what referential integrity constraint does is it ensures that the values in a foreign key column match with the values corresponding to the primary key column in the another table. So it makes sure that roll number 1 is there, roll number 2 is there, and roll number 3 is there. So it basically makes sure that the foreign key values and the primary key values remain same or remains consistent. I guess this is the fourth one. So the fourth constraint is key constraint. It is the simplest constraint. So basically it ensures uniqueness for the primary key. So what does this key constraint does is it makes sure that there is at least one primary key which is existing in the table. So there could be like many keys, right? Consider that there is a table, student table. Now we are having student ID, student roll number and student phone number. Phone number is also something which can remain unique for every student. Student ID is also something which will remain unique for every student. Student roll number is also something which will remain unique for every student. So basically key constraint makes sure that there is at least one attribute or at least one key which is they're present in the table which will be serving as a primary key. So it ensures the uniqueness for the primary key. Now the fifth one is the check constraint. So what does this check constraint does? As I told in the previous slide, we put a check for the age key. Age should always be greater than 0. If the age is greater than 0, only then go ahead and insert the data in the database. So check constraint basically checks for a condition that each row in a table must satisfy. If the condition is not met, the insertion or the update of the row is rejected. So consider that if we are giving age as -5, which is not passing this particular constraint, so basically this particular data is rejected and we can't insert this particular data in the database. Consider there is already existing data where age is 11. Now I update this particular data to -5. So the check constraint will check if the age is greater than 0. If not, it will not perform this update operation. Now the sixth constraint is the null constraint. It determines whether a column in a table can have null values or not. So basically this null constraint is given to some optional fields in the database. So consider that there is a student table. Now in that particular table we have a section called as student email. So there could be a possibility that many students don't have email, many students may have email. So that particular column is an optional column. So what happens ki if we give that particular null constraint, so what it will do is ki it will verify that if this particular column is an optional column or can accept the null value. See, if we give a null constraint, it will automatically fill null there. So basically if we left that particular attribute as empty, it will take that value as null. So basically it is like to make sure or to provide an additional check ki theek hai, there is a email attribute or there is a email column which many students may have email, many students may not have email. So you can go ahead and put null value in that particular attribute. There shouldn't be any case where we are inserting the values and we are not able to insert it because the email section we are leaving it as blank. Now I guess this one was the sixth. Okay, this one is the seventh. So unique constraint. Now unique constraint ensures that the value in a specified column or a combination of columns are unique across the table. This constraint prevents duplicate values from being inserted into specified columns, maintaining data consistency and integrity. So basically you have heard na ki primary key is attribute which is unique plus not null. So what does this unique means? Unique means na ki whenever we are inserting any values, it is unique. So consider that there is a table, student table. Every time I'm taking this student table example. So basically there is a student ID, right? And this is acting as a primary key for the student table. So consider that for one person I've given the student ID as 01. For one person I've given the student ID as 02. Now for the next person I can't give the student ID as 01 because it will then not take into consideration this particular unique constraint. So whenever we give this unique constraint to any particular attribute or any particular column, it makes sure that if 01 value is inserted, it is not inserted next time. So there won't be any duplicate values. So basically this constraint prevents the duplicate values from being inserted into specified columns, maintaining data consistency and integrity. So 01 if inserted cannot be inserted next time. So basically unique means unique values will only be inserted. Every time new values would be inserted, none of the two values can be inserted which are same. Now the eighth constraint is default constraint. So what does this default constraint mean? As the name suggests, default. So consider if you are inserting values into your table, right? So if there is no value for a particular field or for a particular column, so there would be some default value which would be inserted for that particular field or that particular column. So basically it ensures a default value for a column which is used if no other value is provided. So consider that there is a field called as Aadhaar number. Okay. So for the students who are having Aadhaar number can go ahead and enter their Aadhaar number. But for the students who are not having their Aadhaar number, I want them to have no Aadhaar. So basically for the students who are having the Aadhaar number, they can go ahead and insert their Aadhaar number. But for the students who are not having their Aadhaar number, I want a default value to be inserted that they are having no Aadhaar. So basically default values comes into picture in this case. Ki what will happen that student A will try to insert his or her data. Now whenever the Aadhaar field needs to be inserted or the Aadhaar data needs to be inserted, student will leave it as blank because they don't have any Aadhaar, and a default value called as no Aadhaar would be inserted in that particular case. So what is super key? So before knowing what is super key, I would like to re-revise some concepts of primary key and candidate key. So consider that there is a table of student. Okay. So basically consider that there is a student schema. Now in this particular schema, there would be some attributes or columns. So consider that there are attributes such as student ID, student name, student phone number, and student Aadhaar card. Okay, so basically this is the student schema. Now in this particular student schema, we need to know what is the candidate key and the primary key. Now what is candidate key? Candidate key is basically attribute or set of attributes which can uniquely identify records in a table. So any attribute which could help us to uniquely identify the records in a table is called as candidate key. So basically for the candidate key, let's have a look through on the schema one by one. So the first attribute in the schema is student ID. Now does student ID qualifies to be a candidate key? Yes, it qualifies, because student ID is something which can uniquely identify records in a table. If I give a query or if I make a query based on student ID, give me the details of that particular student whose student ID is 001. So it will give me the details of that particular student whose student ID is 001, and none of the students would be having the same student ID. So it is kind of uniquely identifying records in the table. So student ID is a perfect option for the candidate key. So what I'll do is I'll mention it in the candidate key set. Now second is the student name. So there could be a possibility now that two people or two students are having the same name. Consider that there are two students in the class and they both are having the name as Abhishek. So basically if they both are having the name as Abhishek, there is a possibility that if I make a query based on student name, I could get some details of another Abhishek, but I want the details of Abhishek whose student ID is 002, but there is a possibility I can get details of Abhishek whose student ID is 003. So because of this case, we discard this particular student name from being a candidate key. Now the third one is student phone number. Again, phone number is also something which can uniquely identify records in the table. Like if I give the phone number of a particular student, so it may give me all the details of that particular student, and phone number is something which can't be same for every person, and we can give this as a possible option for candidate key. I'm not talking about primary key, but it can be a possible option for candidate key. So student phone number is also something which can be a possible option for the candidate key. Now the next one is student Aadhaar. Again, Aadhaar is something which is unique for every student, so we can give it as a possible option for our candidate key. So student Aadhaar is also in the candidate key set. Now the next key is the primary key. So basically there are two differences between candidate key and primary key. So basically candidate key is something which uniquely identifies the records in the table. But in case of primary key is a key which comes from a candidate key or is a key which is derived from the possible options of candidate key. Also, primary key is something which should always be unique and which shouldn't be null. So basically if these two constraints, unique and not null, is present in a particular column or in a particular attribute, it qualifies to be a primary key. So basically there are three candidate keys here we have seen. Now among these, which can be a primary key? So student ID, again whenever any student takes admission, they have the student ID or the student registration number generated. So it will be unique for every student, and it is obvious that every student who is taking an admission is having a student ID. So student ID is always unique, plus student ID is never null. So student ID can be a primary key. Now coming to student phone number. Now consider that there are many students who don't have phone number or who can't give their phone number, like we are going into the 90s era. But there could be a possibility that students can't give their phone number, or there could be a possibility that there are siblings in a class who are having the same same father, and due to the same father they would be having the same phone number. So again, student phone number is something which can at times remain unique but at times can't remain unique. So student phone number is something right now we won't be giving a possible option or considering a possible option for primary key. So for now I am discarding student phone number from the primary key. Now again the third attribute is student Aadhaar. Student Aadhaar is also something like many students may not have their Aadhaar card number generated or Aadhaar card made. So there could be a possibility that some people might have Aadhaar card section as null. So basically as primary key is something which is unique plus not null. So Aadhaar card is also something right now we can't consider in the primary key. So from these particular discussions we have come that student ID is something which qualifies for a primary key. Candidate key, a key which uniquely identifies all the records in a table. Primary key, a key which uniquely identifies all the record in a table but it is unique plus not null. Now coming to the main topic, that is super key. So basically what happens now ki in super key is basically a set of attributes which uniquely identify records in a table. Now why super key came into picture? So consider that there is a candidate key, okay? So there is a candidate key SID, okay? For now, let's consider only one key. So in candidate key, student ID is there. Now, super key is basically a superset of candidate key. Superset means ki super key, if there is any combination of super key or any composite keys which are present, there would always be a candidate key. So whenever we are adding more attributes to the candidate key, it becomes a super key. So you can understand in this way ki primary key is something which is derived from the candidate key, like from all the possible options we select the best option to be the primary key, and in super key we consider all the attributes of the candidate key or some of the attributes of candidate key, plus there are some extra attributes which is also added, but candidate key is something which is always must in a super key. So if we are making any super key or combination of super keys or composite keys, there should always be one candidate key. So what happens in super keys, ki consider that right now this is also called as super key. So what is this is called as minimal super key. Since there is only one attribute, we can call it as minimal super key. So what is minimal super key? Minimal super key is basically called as candidate key. So whenever there is minimal or there is minimum attributes which are present and the attribute reflects that of candidate key, it is called as minimal super key. Now super key is something which is having a candidate key, and then we can have some more attributes from our particular schema or from our particular table. So basically candidate key is having all possible attributes which can uniquely identify records in a table. Super key is something which is taking into consideration the candidate key. Apart from candidate key, it is also taking some extra attributes into picture to make that particular combination. So what will happen here is key candidate key is student ID. Now super key, minimal super key is student ID. But if I want to make super key, I can also make a combination of student ID and student name. So basically this can act as a super key for me. So what it will do is ki give me the details of a person whose student ID is 001 and whose student name is Riti. So it will fetch me all the records, all the details of that particular student whose student ID is 001 and student name is Riti. So basically it is also a set of attributes which is helping us to uniquely identify records in a table. But super key is something there can be much more attributes which is like not needed really to identify records in a table. But super key is something which will always have at least one candidate key. So basically it is a set of one or more attributes that can uniquely identify a tuple in a relation. Superset of any candidate key is called a super key. A super key becomes a candidate key if it is minimal, that is no proper subset of it can uniquely identify a tuple. Now let's see one small example. Won't extend the video much. So let's have a look at small example. It's kind of a small numerical, you can say, for now. So let me just rub it very quickly. Till then, again I am reiterating. Candidate key is the set of attributes which uniquely identify records in a table. There could be one or more attributes. From all those attributes, we choose the best option, and that is a primary key which is unique plus not null. And super key is a combination of set of attributes which have at least one candidate key. So these were the meanings about all these. Now consider that there is a employee schema. Okay. So there are many employees, E1, E2, E3 till En. Now consider that we have given that in this particular schema, E1 is the candidate key. So I need to know that how many super key can be possible, how many combinations of super key can be possible. So basically we have an employee schema. In that particular employee schema, there are n number of employees. For now I am not defining the number n. There could be 8, there could be 18, there could be 800, there could be much more. So we are taking n into consideration. So there are n number of employees in a company or whatsoever you think. So there are n number of employees. For that n number of employees, there is one candidate key, that is E1. Now since we have one candidate key, we need to find out how many super keys are possible, how many combinations of super key are possible. Now let's start. So basically you guys might have read about probability. So what will happen, ki there are two possibility of E1. Either E1 can be a part of combination, either E1 can't be a part of combination. Either E2 can be a part of combination, either E2 can't be. Either E3 can be or can't be. Either En can be or can't be. So right now E1 is the candidate key. Now whenever we are making a super key from that, so E1 is a candidate key, so E1 E2 can be a possible combination. E1 E3 can be a possible combination. E1 En can be a possible combination. E1 needs to be there every time, because as I told that super key is something which is having at least one candidate key. So at least one candidate key needs to be there. So there can be multiple combinations from this, right? And every E1, E2, E3 can have two types of they can have two combinations. Either they can be there or they can't be there. So E2 can be there or E2 can't be there. So there are always two possibilities for that. So if we calculate it from here, 2 till n, so it can be called as 2 to the power n. But again, E1 is something which is remaining, like it's evident in all the combinations, right? So E1 is also there, E1 is also there, E1 is also there. If I'm doing E1, E6, E1 is always there. So E1 is something which is always there. So there is no possibility that E1 will never be there. There is only possibility that E1 will always be there. So what we do is ki after that, the final remains is ki 2 to the power n minus 1 can be the super keys. How it is 2 to the power n minus 1? So basically every E1, E2, E3, E4 till En has a possibility that it can be there, it can't be there, it can be there, it can't be there. But one of them is the candidate key. So when one of them is the candidate key, the possibility of not being there is vanished. So there is only possibility of being there. So we do it 2 to the power n and minus 2, that was 2 to the power n minus 1. So basically 2 to the power n refers to all of the possible combinations, and eliminating one combination from this is 2 to the power n minus 1. So now the first question comes into mind is, what is ER model and why we are learning ER model? So let me just explain you from a very small or basic example. Consider that you are a developer. Now you have to make an API, okay? So you have to make all the API, all the calls which are present in that particular API, all the database calls and everything. So basically there could be an API in which there are some clients which are being called, some database queries which are being done, some database calls which are done. So basically an API have many calls, okay? Now your team leads come to you and explains you, okay, this API is doing this, and finally giving the result. So you are having a request body and you are getting a response body. Now what happens is कि team lead comes and tell you about all these. At that particular moment of time, you remembered कि okay, this particular thing is being called, then there are some clients being called, then there are some database queries which are being happen or database calls which are being happen, and then we are getting the final response. Now consider after 3 days you forgot about one client, or you forgot about one DB call, or consider that there are some changes which is happening and you are not still pretty sure that what all things you were doing at the very first, and now you need to do some changes as well. So what thing you can do at that particular time? So at that particular time, what you can do is कि when your team lead is explaining you, just jot it down in pointers and make a low level design of that particular API. So what you will do is कि you will make a design of that particular API कि okay, the API is getting some request, it is validating some request, and then it is calling some clients from there, it is fetching some data, then it is calling the database, and after all these we are building the final response. So basically LLD diagram at that particular point would save a lot of time of yours, because you would be pretty sure about ki what all things are happening. And also you can ask your team lead ki please review my LLD diagram and is my understanding about the API correct, or is there any changes needed, or whenever your team lead suggests some changes, you can just go ahead and make the changes in the LLD diagram. So you can see in a diagram or design is somehow like making things so much easy and somehow also saving our time, right? So in the same way, like a very basic example of Maggie. So consider that you are making Maggie for the first time. Now you need some instructions that how to make a Maggie. So whenever you see that Maggie packet, you see in the background there is, like in the back, there is some pictures which is given and there are some instructions which is provided. Okay, then tear the plastic and then boil the water and then put the masala and then the noodles and stir it for 2 minutes. So there are some instructions which is being provided, there are some images which is being provided. You just follow that and you are like good to go to make a Maggie. Okay, so basically what happens, like whenever you are following any design or any diagrams, it makes task very much easy for you to implement ultimately what you wanna do at the very first point. So in the entity relationship model, what happens is ki ER model basically help us in designing a flow chart or the diagrams or everything which is needed for our like entities, relationship, and what all things are being happened. Now consider, let's take an example of Instagram. So in Instagram, there are many features present there, adding a story, uploading a post, and much more things. So consider that today I told you that implement the feature of uploading the post in Instagram. So there are many steps which are being followed. First, you select the picture, click on the post plus icon, then you select the picture, and then you go ahead and see if you want to apply some filters and much more things. So there are many steps which are being involved for uploading a photo in Instagram. So all these steps, if documented in a very great way or in a very good way, it is diagrammed and designed, it would be very easy for you to understand the overall API of uploading the post, and also it would be very helpful for you to implement that particular API. So in the same way, ER models makes our task easy. So now what is ER model? ER model basically stands for Entity Relationship Model. Now as the definition suggests, entity relationship. What is entity? Any object or anything which is having some physical existence is called as entity. For example, consider person. Person is an entity. Example, student. Student is an entity. So basically anything or any object which has a physical existence is called as entity. Now what is attributes? So basically the characteristics of that particular entity is called as attributes. So you might have heard this term schema in the last set of videos. So what is schema? Consider that I need to give student schema. So what I'll mention is I'll mention the entity name and then I'll provide all the attributes such as student ID, student name, student roll number. So in the same way, it is this is a schema of student. This is a student schema. So in this particular student schema, student is the entity. Student ID, student name, student roll number is the attributes. And now coming to the third thing, that is relationship. Now I have given many examples where I have taken two tables. First one is student table and second one is a course table, which was having a primary key, foreign key relationship between them. So in that particular videos, I also told that student is having some relationship with the course. So basically student and course have a relationship. Ki student is taking this particular course for that particular class or that particular standard and that particular roll number. So basically a student is taking this particular course. So basically there was a relationship between student and course table, that student is taking or opting or studying that particular course. So in relationship what happens is we define it in a diagrammatic way. So what will happen is there is a student database. Now there is a course database. And now what is the relationship between student and courses? Student studies course. So basically we give student in rectangular format and study like the relationship in the diamond format. So what happens is student is now studying a course. So basically entity relationship model is we define the relationships between the entity that is studies, and entities are present here, and attributes are basically the characteristics of entities. So attribute can be student ID, which we give in ellipse, then student name and much more things. So basically this is the basic funda of ER model. So let me just clear the screen and let's go one by one. Okay. So So introduction to AR model. Entity, things or objects is called as entity. Example, person. Now attributes, properties of entities or characteristics of entities called as attributes, such as names, age, student ID and much more things. Relationship is association among the entities, that is works for or studies or like much more things. Okay? Now the entity relationship model stands as a prevalent conceptual modeling approach within the realm of the database design. Its primary role is to offer a visual representation of a database architecture by illustrating the entities, their respective attributes and the interconnections between them. So what is happening is it is basically a virtual representation of a database. So the database is very huge. Now in that particular database there are some tables which is having some relationships in between them. So what will happen, we will just design that particular database. So consider that there is a student database. In that particular database there are many tables, student table, course table, then fee details and much more things. Now it will define that what are the relationship between these particular entities. In the process of database design, the ER model holds significant importance, aiding in the development of an efficient and systematically structured database schema. So as I told, if I am having an LLD diagram, I can design, I can implement the API very quickly. If someone who is very new to that particular API and don't know anything about that API, if I give him the LLD diagram, him or her, they can implement the API very easily. So basically LLD diagram or visual represent or designing is something, if we hand over to anyone, it will make the process very easy. The designing of the database, when it's done, we can go ahead and implement the database, we can go ahead and know about the database, what all tables are there and much more things. So basically it is somehow making our task very easy. Now in the ER model, as I told, that ER model starts for entity relationship model. Now there is entity, there is attribute and there is relationship. Now there are types of entities as well, strong entity and weak entity we will be knowing in the coming videos. Now in the attributes also there are many attributes like simple, composite, single valued, multi-valued, stored, derived, composite. So basically about all these attributes we would be again knowing in depth in the next set of videos. I'm just letting you know that there are entities also divided in some subtypes, attributes is also divided into subtypes and relationship is also divided into some subtypes. Relationship, or also called as cardinality, is also there: one to one, many to one to many, many to one and many to many. Now these are the symbols which is basically used in the ER model. So as I told, consider that there are two entities. So firstly I'll give the schema. So I'm giving the schema for student and course. Now student schema has student ID, student name, and course schema has course ID, course name. So what is this? This is basically entity. So what I'll do is according to the symbol, entity is represented by rectangle, so I'll give the name student. Now again course is also one entity, so I'll give it in rectangle shape, course. And now attributes are represented in ellipse. So attributes are nothing but the characteristic, so we'll give the attributes student ID, student name, and then the attributes for this: course ID, course name. And now at the very last we give the relationship among them. So from the diamond it is given and the relationship is study. So basically in this way we design the ER model. This is a very basic ER model design. We would be knowing in much more depth about some complex database designs as well. But this is just a small example that how we are designing everything from entity to attributes to relationship. So basically this is the student schema, this is the course schema, and whenever we have this particular schema we can go ahead and design our entity relationship model or design the visual representation of that particular model. So there are much more things like line is like attribute to entity relationship. Now double ellipse is multi-valued attributes and double rectangle is weak entity. As I told here that there are many subtypes of attributes and entities, so we would be looking about that in the next set of videos. Now, this is a normal example of ER model as I explained earlier as well. So there is an entity called as professor. There is an entity with the name student. Now there is a relationship between the professor and the student, that is teaches. So basically relationship is teaches. Now student may have some characteristics or may have some attributes. So that attributes is represented using ellipse, and the attributes are ID, name and subject. So these are the attributes. This is the entity, this is the entity, and this is the relationship. So basically in the last slide I also explained about this particular example of student and course. In a similar way there is example of student and professor. So this was all about ER model in this particular video. Let me just revise from the very basics. So ER model stands for entity relationship model. Entity relationship model helps us to give a visual representation of our database, so that designing of database, when it becomes easy, the implementation of database also becomes easy. So ER model is entity relationship model. Entity is basically any object or anything which has a physical existence. Relationship is a relationship between the entities, and attributes is basically the characteristics of the entities, like student ID, student name for a student table, and course ID, course name for a course table. Now again, entity and relationship have some subtypes, also attributes also have some subtypes. So about all those types and about all the types of entity and relationship we would be having a look on next video. Basically it is providing a visual diagram to us which would help us to implement the database very easily and very effectively. So what is an entity? An entity is something from the real world, like a person, place, event or idea that has some physical existence. Now each entity has specific features or traits that can describe it. Now consider that I am taking an example of person. So person is an entity because it is like a real world object which has some physical existence. Now person may have some characteristics, which could be person name, person age, person address, and much more things, right? So all these characteristics are called as attributes of a person. So that is told here that each entity has some specific features or traits that describes it. So basically person name can describe it, person age can describe that the person is having this age, the person address can describe that the person lives here. So there are some special features or there are some traits which particularly define an entity, that is called its characteristics or attributes. Now there are two types of entities. First one is a strong entity and second one is a weak entity. So let's have a look on that. So types of entity. First is the strong entity, second one is the weak entity. Here I have given an example of person entity and dependent entity. So what is strong entity? From the word you can see now, कि strong entity is something which is strong, right? So a strong entity is basically an entity which does not depend on any dependent or does not have any dependence on other entities. So basically it can exist alone. So let's take an example. Consider that we have taken an example of person entity here. So why person entity is called a strong entity? So person entity itself can define all the attributes of the person, like the name, the age and much more things. So it's not dependent on other entities ki, okay, here you get the details of, okay, Raj is a person who is having an age as 20 and the phone number is this, the Aadhaar card number is this, and much more things you can know here. So it is independent. It does not depends on other tables or other entities to gather information, or like it can independently exist. So basically a strong entity is something which can independently exist. It does not depends on other. Second thing is strong entity is an entity which is having a primary key. Now coming to the weak entity. Now what is weak entity? Now consider that there is a person table, right? And in the weak entity I have given the dependent table. So basically person has some dependents. Consider that there is a person who has some dependents like his mother, his father, his children and much more things. Now if the person table is not there, would you be able to know that, okay, there is a section called as mother and the mother name is given, but whose mother is this? So if the person table is not there, you won't be able to know that whose particular mother or whose particular person mother is this. So basically dependent table is something which is kind of dependent on the person table, because person table is somehow like the dependent table is somehow gathering information from the person table, and this particular table is solely dependent on this table, that the parent is this, the wife is this, or the children is this. Let's not confuse you. Let's go ahead and have a look on the definition first, and then again we will learn from an example. So basically types of entity. Strong entity. A strong entity is an entity that has its unique identifier, that is primary key, and it's not dependent on any other entity for its existence within the database. Strong entities stand alone and have their own set of attributes. Example, person. Now in the weak entity, a weak entity is an entity that does not have a primary key of its own. It relies on a related strong entity known as owner entity for its identity. The weak entity existence is defined by being related to the owner entity. Now example is dependent. Now let's understand the strong entity and weak entity in detail. So consider that there are two tables. So first is the student table and second is the course table student has taken. So it has course ID, course name, it has student ID, student name, and student age. It also has the student ID. So do you remember in last set of videos we learned more about primary key and foreign key relationship. So basically there are two tables. One is a student table, one is a course table. Basically student ID in the course table is a foreign key which is taking reference from the primary key in the student table. Now what happens ki consider that there are two entries. First one is Riti, second one is Ram, and the age is 20, 21, and the course ID here is 01, 02, course name is physics, course name is maths. The student ID is 1 and 2. Now from these two tables it's evident a person or a student whose roll number is 1 has taken the course name as physics and course ID is 01. A student whose ID is 2 has taken a course name maths and is having a course ID as 2. So from where do we get the details ki who is roll number 1 and who is roll number 2? From this particular student table. So student is an example of strong entity and course is an example of weak entity. Let's understand how. So basically student table can exist independently. It doesn't need to gather information from some another table ki okay, for roll number 1 what is the student name or what is the student age. It can exist on itself. And also the second thing is ki this particular table is having a primary key. This is a foreign key. So basically there are two things which are needed for an entity to be a strong entity. First one, that the entity should exist alone. If there are any hindrance in another tables, it shouldn't affect this particular table. So it can exist alone. The second thing is the table always should have a primary key. So all these two things are verified in this particular student table. So student is a strong entity. Now coming to the course table. So basically course is somehow having a foreign key primary key relationship with student. So it is called as a weak entity. Because again I told na ki there is one student whose roll number is 1 and has taken course name as physics and course ID is 01. But what if this table is not here? So would you be able to find ki okay, roll number 1, who is the person who is roll number 1, or who is the person whose student ID is 1? Would you be able to find ki 2, who is the student who is having the student ID as 2? So this table can't exist independently, and it also doesn't have any primary key. It just have a foreign key which is taking a reference from the student table where student ID is acting as a primary key. So basically it can't exist alone and it doesn't have a primary key. So it is called as weak entity. Basically strong entity is represented by one rectangle and weak entity is represented by two rectangles. And whenever there is a relationship between a strong entity, that is student, and a weak entity, that is course. The relationship among them is defined via two diamonds. Studies. So this is student, which is a strong entity, so a single rectangle. Course, which is a weak entity, so two rectangles. So basically this is the way we represent entity relationship between strong and weak entities. Attributes in DBMS. Now what is attributes? So I told that entity is something which is basically having a physical existence. So basically whenever I am taking an entity example, consider person. So basically person is an entity. Now person may have some characteristics such as person name, person age, person address, and much more things. So these are the characteristics of person which we generally called as attributes. So basically these are called as attributes. Now in attributes also there are some types of attribute about which we would be learning in this particular video. So types of attribute. So the very first attribute is a simple attribute. As the name suggests, something which is very simple, or like simple attribute is something which can't be further divided. So a simple attribute is an atomic and cannot be divided any further. Example, first name. So consider that there is a student, right? So student would be having name as an attribute, and name can further be divided as first name, middle name, and last name. So basically these all three, first name, middle name, and last name, these are the attributes which are called as simple attributes because they can't be divided further. Name can be divided further. Name attribute can have more attributes such as first name, last name, middle name, in such a way like address attribute can have street, city, pin code, and much more things. So in the same way, name attribute can have further attributes, but the further attributes such as first name, middle name, last name cannot be further divided. Also there is one more attribute you can take it, an example is age. So age is also an attribute. I have given the student age is 18. Now what kind of further modifications or further division it needs? It needs nothing, right? So basically simple attributes are the atomic attributes which cannot be divided further. So simple attribute is an attribute which cannot be divided further, and for your information, attribute we represent it using eclipse. So we can say first name is a simple attribute. Now coming to the another attribute, that is composite attribute. So going to the same example, so there is a student, so there would be attributes such as name, attributes such as address. So name is again an attribute which can be further divided. So it could be first name, last name, middle name. Address can also be further divided into street, city, pin code. So basically these attributes which can be further divided are called as composite attributes. So composite attributes is made up of several smaller part of attributes where each part represents a piece of a whole attribute. In simpler terms, it is composed of attributes which can be divided further. So name is an attribute which can be divided further. Address is an attribute which can be divided further. So these attributes are called as composite attribute. Example, name, which could be first name, last name, or middle name. Now the third attribute is single value attribute. From the name itself, it's clear that these values or these attribute have a single value. So basically a single value attribute is an attribute that holds a single value for each entity. So consider that again there is an attribute age, there is an attribute student ID, or there is an attribute consider course ID. So all these attributes would only have a single value. So age is considered 18, student ID is 1, 2, 2, 3, or CID is 0, 1, 2. So these attributes can't be divided further and they have single value. So basically they don't have multiple values, they have only single value. Consider that student phone number. So there could be multiple values for phone number. Consider you are giving your father phone number, your mother phone number, or your local guardian phone number. So phone number is something which can have multiple values, but age is something you can't say na ki a student is 18 and 21 at the same time, right? So age is something which is a single attribute. Now again, student ID is something which is unique for every student. So you can't say ki my student ID is 1223 and 1224. So it's not possible, right? So it would always have a single value. So basically a single value attribute is an attribute that holds a single value for each entity. Example, age. Now next attribute is multi-value attribute. As from the single attribute it's clear, single attribute is something which is having a single value. Now multi-valued attribute is something which is having multiple values or can have multiple values. So a multi-valued attribute in a database is an attribute that can hold multiple values for a single entity. Example, address. So you have filled so many forms, right? So in so many forms you can see, or in the diary itself, whenever we take admission into any school, in the diary itself you can see there is two fields for address. One is permanent address, second is residential address. So basically address is an attribute which can have multiple values. Consider that permanent address and residential address. So basically attribute is something which can have, this address attribute is something which can have multiple values. So basically an attribute which can hold multiple values is called as multi-valued, and an attribute which needs only single value or can hold only single value is called as single-valued. So basically in multi-value attribute we represent the attribute using two circles. So address can be represented in this way. Now next attribute is stored attribute. So attribute that is stored as a part of database record. So in stored attribute, it is an attribute which can be stored. Consider date of birth. So date of birth is an attribute which can be stored, right? So date of birth is something which you can store and you can give to the system. Now coming to the next attribute, that is derived attribute. So a derived attribute is derived from other attributes within the database. Like age is derived from date of birth. So right now I told you about stored attributes. So date of birth was something which was a stored attribute. So we stored the value of this attribute in the database. So it is called a stored attribute. Now from this date of birth, consider that there are many employees in my company and they have given their date of birth, and I want to know the age of that employees. So from the date of birth itself we can know the age of that particular person. So basically age is a derived attribute taking reference from date of birth. So derived attribute is something we represent through dotted ellipse. So age is something which is being derived from date of birth. Consider in case of salary also. So in salary there are multiple parts. So first is base, second is the stocks, third is the bonus. So using all these attributes we derive the total salary. Just a second. So we derive the total compensation, that is TC. So basically TC is something which is getting derived from other components such as base, stocks and joining bonus. So basically total compensation is something which is a derived attribute and it is being derived from base, joining bonus and much more multiple components. So we can say that as a stored attribute. So the next attribute is complex attribute. So complex attribute is an attribute that is made up of multiple smaller attributes. So whenever we made attributes from smaller attributes, it is called as complex attribute. Consider an example of address. So basically in address, it is a composite attribute because it can have attributes such as street, pin code and city. And at the same time, address is also acting as a multi-valued attribute because address can be of can hold two values. First one is permanent address and second is residential address. So basically residential and permanent are the two values it can hold, and it is a complex attribute because it is a composite attribute because it can be further divided into simpler attributes. So there is one more attribute, that is a key attribute. So basically key attribute is something related to uniquely identifying records in a table. So basically a key attribute is an attribute which helps to uniquely identify records in a table, and it's always unique. So key attribute is something which is always unique. So consider that in this particular case of student, let me just write it here. So student, there can be multiple attributes: student name, student age, student ID. So again, student name is something like two people can have the same name. Student age is also something like two people can have the same age. But student ID is something which is always unique. So it acts as a key attribute, and whenever there is a key attribute, because it is acting like unique, it is acting like uniquely identifying all the records in a table, we represent the key attributes using a small line inside the ellipse. So basically, let me just re-revise about all the attribute symbols. Okay, so basically attribute is represented using ellipse. Now there is a derived attribute which is represented using dotted ellipse. Now there is a key attribute which is represented using ellipse, and inside there is a line, and then there is a multi-valued attribute which is represented using double ellipse. So this is a simple attribute, this is a derived, this is a key, and this is a multi-valued. Now let's see at the term what is the types of relationship. So basically like types of attributes and types of entity. In types of entity we got to know more about strong entity and weak entity. In the same way here also strong relationship and weak relationship exist. So let's see that what is strong relationship and what is weak relationship. So first we'll start with the strong relationship. Now what is a strong relationship? A strong relationship exists when two entities are highly dependent on each other and one entity cannot exist without the other. So basically a strong relationship is established between two persons when they are inseparable, right? So in simpler terms, that when two people are inseparable, they have a strong relationship, and when they can be separated, somehow they have a relation but they can be separated, is called as weak relationship. So in this case, strong relationship is when an entity is highly dependent on another entity and cannot exist without another entity, that is called a strong relationship. Now here I have taken an example of customer and order. So okay, so basically there is a customer and there is an order. Now every customer places some order, right? So every order is placed by a customer. Now in customer there would be some attributes such as customer ID, customer name, customer address, and much more, right? And order also may have some attributes such as order description, order ID, and much more. Okay, so what happens is ki for every customer there is a order, right? So for every customer ID, there is a order which exists in this particular table. Now what will happen when I delete this customer table? So there would be some customer IDs present, but these customer IDs does not exist because the table does not exist. So in the very starting of the video, I explained about primary key, foreign key relationship. So basically in this customer table, the attribute CID is acting as a primary key, and in this order table, CID is also present and it is acting as a foreign key which is taking a reference from the primary key of another table, that is the customer table. So they have a relationship established between them. Now what if I delete this customer table? So all the customer details would be gone, all the customer IDs would be gone. Now here from this customer ID, this table is taking reference from this particular table, but since this customer ID is deleted, or this customer table which is having a customer ID is deleted, it won't be able to take a reference. So they both are dependent on each other. So basically the one which is having a primary key is called as parent, and the one which is having a foreign key which is taking a reference from its parent is called as child. So basically here the child has a foreign key, here the parent has a primary key, the child is having a foreign key which depends on the primary key of parent. So if the parent is deleted, the primary key of parent is deleted, then the child won't be able to take any reference from the parent, and it will result in the referential integrity rules breaking. I made a video on the same, that how the rules are breaking in referential integrity and how we can achieve that referential integrity is also there. So referential integrity rule would be broken, so in this way a relationship couldn't be established. So this is called a strong relationship. Strong relationship means something which is inseparable. So when two entities depend on each other for their existence is called a strong relationship. Whenever there is anything which happens to one table, it affects the other table. Now the second is the weak relationship. Again, I told ki strong relationship is something where things are inseparable. It couldn't be separated. But in weak relationship, we can try to separate them. It won't affect much. Okay. So a weak relationship on another hand exists when two entities are related, but one entity can exist without the other. So whenever there is a use case when one entity can exist without the another entity, that is a weak relationship. Let's understand from an example. So here I have taken two entities. The first entity is order, the second entity is order item. Now order is having a order ID as primary key. Order item is having a order ID as foreign key, which is taking reference from the order table. Now order item also have a order item ID, which is a primary key in this order item. So basically consider that this is a order item table and this is the order table. Now order table has order ID, order name, order description, and order item is having order item ID, OIID. So just make it OIID, order item ID. Order ID, which is basically taking a reference from this table, which is called as foreign key in this table, and consider order item name. Okay. So now this particular order item ID is acting as a primary key here. So basically order ID is a primary key in the order table, which is a parent table. And order item ID has order item ID as the primary key. Sorry for confusing with the words. So order ID is a primary key in order table, and order item ID is the primary key in order item table. So basically this is also having a primary key, this is also having a primary key. Now there could be chances na ki you place a order and order item details and everything is attached to that particular order, but order item is something which can exist independently as well. Like there might be some products in backlog, or there might be some products which is not yet bought by you, so they are our order items. So basically order item is something which can exist independently even if there is no order table. So a weak relationship is a relationship where the two entities are related but one entity can exist without the other. So basically order item can exist without order, but yeah, at the time of making order, whenever a customer places the order item are attached to that particular order, but before placing of their order, the order item can exist independently. So this is weak relationship. Strong relationship, when things are binded, can't be separated. Weak relationship, things can be separated but they somehow have a relationship between them. Now what is degree in DBMS? So a degree in DBMS refers to the number of attributes or columns that a relation or table has. So basically the number of attributes your entity is having is called as degree. It's degree. So consider that there is a customer table. Now customer may have some attributes, customer ID, customer name, customer Aadhaar details. So the degree is 3. So basically the number of attributes or the number of columns in a relation or in a table is called as degree. Now here is the type of degree. So degree is 1. The name we told it as is a unary degree. And a relationship with a single attribute is called as having a unary degree or degree 1. Now degree 2 is called as binary degree, and a relationship with 2 attributes is called as binary degree. Now degree with 3 is called as ternary degree, and a relationship with 3 attributes is called as ternary degree. A degree of n is n array degree, and a relationship with more than 3 attributes is n degree, where n is greater than 3. So consider that there are 2 entities. Let's make a schema of person and customer. Now this person schema may have some characteristics such as person name, person age, and this customer may have customer ID, customer name, customer address. Now to calculate the degree for this particular entity and this particular entity, what we do is we calculate the number of attributes. So here it is 1, 2. So basically it is 2, so it belongs to binary degree. Now in customer table there is customer ID, customer name, customer address. So 1, 2, 3. So basically the degree is 3 and it is called as ternary degree. So in this way we calculate the degree. Now null value. So in DBMS, a null value can occur for various reasons. Not needed information. Sometimes some details are asked, but they don't apply to everyone. For instance, asking for a spouse name for someone who isn't married. So basically, what is null value in DBMS? So you might have seen many places, or whenever we create some tables, we give that this can be null or this can't be null. So some of the attributes we give that this can be null or this is optional. So consider that student is filling Aadhaar card details or PAN card details. It's not possible that each and every student would be having a PAN card. So we can't make that particular column a mandatory, or we can't make that particular column not null, because null values can exist. In the same way, there is some not needed information. So basically consider that you are being asked your spouse name, but you aren't married, you are a single person, so you won't fill any data. So that particular data would be filled with null value. Now here are the instances that why null value basically is used, or what could be the simple use cases why the null value exists. So the first use case is not needed information. So whenever there is a not needed information, we can use the null value. Now second is don't know the answer. Every now or then we are asked a question, but we don't know an answer yet. So you may have dealt this in day-to-day life, that you are asked a question and you simply blank out because you don't know the answer. So in that particular case also null value can exist. So there are some hypothetical questions which are being asked. Do you think a bird can fly, walk, cry, eat at the same time? So again, it's a very lame example, but again there are some questions about which you don't know the answer, so you can put it as null. So basically null value can come in that place as well. So the third thing is forgot to fill in. Like when you are filling out a form and you accidentally miss putting in some important information. So what happens now, whenever we are filling a form, there are some fields marked with asterisk, that these particular fields are required field, but there are some fields which are not marked with that. So what values would be filled for that particular field? So their null value can exist. So sometimes you are being asked that what previous internships you did, but you didn't did any internship. So in that case you make that value or make that field null, like you leave that. So null is automatically put into that. So basically on the types of degree, or on the basis of cardinality, there are 4 relationships. So what are the relationships? First one is 1 to 1, second one is 1 to many, third is many to 1, and fourth is many to many. So in this particular video, we would be knowing in much more detail about 1 to 1 relationship, and then there would be a dedicated videos about all those relationships. So basically starting from 1 to 1 relationship. So before starting, I would like to revise some older concepts of yours. So why are we studying ER model, or why are we studying relational model, and how is it all related to SQL and much more things. So basically what happens now, from the very beginning we read about database schema. So there was a database schema in which we basically used to give the entity name, consider person, and then we used to provide all the characteristics, or you can say attributes, such as person ID, person name, person age. In the same way we do for other entities as well. Now what happened from the database schema, we designed an ER model. As to design an ER model, we need some data like what is the entity name, now what are the attributes of the entity, as well as relationship and much more things. So we designed the ER model using this. Now this ER model, consider this ER model is designed. Now on basis of this ER model, now what we do is from that ER model we derive a relational model. So in relational model what we do is relational model. So in relational model, basically the visual representation which we get, we break it into tables. So basically tables are drawn in ER model, relational model. Now for all these tables, we need to do some coding to make some tables, like to create tables, to insert data into tables and much more things. So that is done using SQL. So basically using SQL, we create, insert, update and do much more operations on the data. Now coming to one-on-one relationship. So what happens in one-on-one relationship? Each row in one table is associated with one and only one row in another table and vice versa. So basically consider that there are two entities. Entity 1 is student. Let me just change the color. And entity 2 is course. Now student is having a relationship with course, that is enrolls. So student is enrolled in a course. Now this particular entities is having some attributes such as student ID, student name and age. This particular entity is having some attributes such as course ID, course name and course professor. Now in this particular entity, SID is the primary key, and in this particular entity, course ID is the primary key. Now these two entities have a relationship among them, that is enrolls. Now basically, can you see that enroll is also having an attribute? So what happens na ki enroll is having an attribute such as enrollment date. So enrollment date is present as an attribute for a relationship table. So what happens ki this particular table, whenever we draw table for the relationship, is called as junction table or associative table. Now coming to the doubts which would be coming in your mind. Now the very first doubt you would be having in your mind is ki we were having a primary key foreign key relationship in the relational models, right? So why do we need an extra table for a relationship? Because ultimately we were establishing relationship of primary key and foreign key between different tables. Now what was the need of introducing a relation table in the very first case? So basically this relationship table or relation table is introduced because consider that there are as I told that there are four relationships: one to one, one to many to one and many to many. So in many to many relationship, what happens now ki generally what happens ki in this particular ER model, what happens ki there is two entities and one relationship. So there would be three tables. In those three tables we generally find out the primary key and we just reduce that three tables into two. But what happens in many to many relationship, now the tables can't be reduced. Right now you won't be understanding these terms. Again I would reiterate these terms after the many to many relationship video, but the first use case was that, and the second use case was ki what if the relation among two entities have an attribute of its own. So basically as you can see, this enrolls is having an enrollment date as an attribute. Now the enrollment date can't be present in the student table as well and in the course table as well, because again it doesn't make sense to make the enrollment date or introduce the enrollment date field in student table or the course table. So basically enrollment date is something which is an attribute of the relationship itself. So for that also we need separate table. So basically as you can see that since there are two entities, what we are doing is ki now we are breaking this ER model into relational model. So what we do while breaking, so there are entities, entity 1, entity 2. So for those separate entities, what we will do is ki we will draw a table. So basically this is a student table and this is the course table. So basically student table is having fields such as student ID, student name and student age. Course table is having fields like course ID, course name, course professor. Now course ID is having CID as primary key because it is uniquely identifying all the records in a table. Now student is also having a student ID as primary key. Again it is also uniquely identifying all the records in a table. Now the third thing which comes is the relationship table. So basically this table is this one. So basically this is a enrolls table. So basically in this table what happens is ki we mention, like, see, as an individual, student is an entity, right? Course is also an individual entity. So from this table we are knowing, okay, student S1 is having name as Ram and age as 14. Here also we are knowing ki course ID is C1, course name is physics and course professor is Saurav. But are we able to know the relationship among these two? In primary key foreign key relationship, what we used to do is ki in the table, like in one table there was primary key, and in another table that primary key was present as a foreign key, which was able to like grab the relationship or was able to make the relationship between these two tables. But right now you can see that SID is present here, CID is present here, but SID is not present in the course table. So there are no relationship between these two tables. So just to establish a relationship, we introduce the relationship table. So in the relationship table, what we do is ki we first write all the primary key of the student table, that is student ID, which is acting as a foreign key here. Now the primary key of the course table, that is CID, which is acting as a foreign key here, and then the attribute of this particular relationship table, that is EDate, enrollment date. Now student ID is given here, course ID is given here, EDate is given here. Now this one table we know that primary key is student ID. Now for this table also we know the primary key is CID. But for this table, what would be the primary key? Because again SID is also something which is uniquely identifying records in the student table. CID is also something which is uniquely identifying records in course table. Now among this, which could be the possible primary key? So among this, any of one could be the possible primary key, either SID or CID. Any one of them could be a possible primary key, because always for one student there is one course, and for one course one student is being enrolled. So one-to-one relationship, what happens is ki only for one particular student there is one course, or vice versa, only for one course there is one student which is enrolled. So basically the student won't repeat ever, the course won't repeat ever. So any of them, either student ID or CID, can be a part of primary key. So basically the very first question arises is ki in the relationship table, which is the primary key. So in one-to-one relationship, any of the attribute which is serving as a primary key in any of the entities can be the possible primary key for relationship table. Now the second question arises in our mind is ki can we reduce this table? So there are three tables. First one is for student entity. The second one is for relationship table or enrolls tables, and the third one is for course table. So basically there are three tables. Can we normalize, or can this table be reduced? So the answer is yes, the tables can be reduced. How these tables can be reduced? So consider, for now I am considering SID as a possible primary key. Now you can see SID is also present here. SID is also present here. Now S1, S2, S3, the values are not repeating. S1, S2, S3, the values are not repeating. And for now, like any of them, either SID or CID, any of them can be assumed as a primary key. For now I am assuming SID as a primary key. So basically what we can do is we can combine these tables into one table, and this table would be as it is. So what happens when we combine SID, SNAME, SH, that is of student table, and SID, CID, EDate, that is of relationship or the enrolls table. So basically SID is present here, which is common among both of them. SNAME is here, SAge is here, CID is here, EDate is here, and then this particular table is here. So basically earlier we used to have three tables, now we used to have two tables. Let's re-revise all the concepts from the very starting. Now what is one-to-one relationship? So one-to-one relationship is established whenever one row or each row of one entity is associated with one row or each row of another entity. So basically one-to-one relationship means each row of one entity is associated with each row of another entity and vice versa. Now in one-to-one relationship what happens is there is two entities and there is one relationship among them. Now for all these three we draw separate tables. So basically ER model is now broken into relational model. So in relational model we draw tables. So basically we draw table for all these three: entity 1, relationship 1 and entity 2. Now in all these three tables, we have first table is the student table, the second table is the course table. Now student and course table stands as an individual entity, but when we want to establish a relationship between the student table and course table, we introduce the relationship table. In the relationship table, we add the primary key of student table, we add the primary key of the course table, which is acting as a foreign key because again it is referencing to primary key of another table, and this one is also referencing to primary key of another table. Along with that, we add the attributes if they are present for the relationship table. Now what happens is the first question which comes into mind is what would be the primary key of the relationship table. So basically from first table, that is student table, we get the SID as primary key. From the second table, that is course table, we get the CID as primary key. But in the relationship table, what would be the primary key? So any one of them, either student ID or course ID, can act as a primary key. Now the second question which comes into mind is can we reduce these tables, because again there are three tables and the relationship table is having a primary key from existing student table also, existing course table also. So can we combine those tables or can we reduce the tables? So the answer is yes, we can combine or we can reduce the tables. Again we can combine those tables, like consider in relationship table, for now we are considering student ID as the primary key. So we can combine relationship table with the student table having student ID as a primary key. If we are taking course ID as primary key, then we can combine course table and the relationship table, which reduces our tables from 3 to 2. So basically this was all about one-to-one relationship among different entities. Right now we are reading about ER model. So ER model basically means entity relationship model. So the relationship between two entities and the visual representation of that, or you can say the designing of that, is called as ER model. Now as the name suggests, entity relationship. So there would be some relationship between different entities. Now what is entity? Any living thing or any living object is an entity. Now they would be having a relationship between them. Now entities is having relationship among them. Consider there is an entity A and there is an entity B. Consider the entity A is customer. Consider the entity B is the order it makes. Now there would be a relationship between customer and orders. What could be the relationship? Customer, place, order. So place is a relationship between these two. Now there are some mapping constraints which are present when we establish a relationship between two entities. So what is this mapping constraint? Mapping constraint are things like one customer can place only one order, that is one-to-one mapping constraint. One customer can place many orders, that is one-to-many mapping constraint. So basically the relationships or the connections or how these entities are being mapped in the relationship is called as mapping constraint. And there are various types of mapping constraints such as one-to-one, one-to-many, many-to-one and many-to-many. So today we would be knowing all about one-to-many. So I guess without any further delay, let's get started with the lecture. So one-to-many relationship. A database model where one entity on one side of the relationship is associated with multiple entities on the other side, it is called as one-to-many relationship. So basically what happens in a database model, when one entity is associated with many other consider that there is one record which is associated with many other records in the other side, or you can say in the other entity, then that is called as one-to-many relationship. So let's see from an example and understand from an example. So there are two entities. First one is an author entity, entity E1, and second entity is the book entity, that is entity E2. Now author reads book. Reads is the relationship between these two entities. Now there are certain characteristics of entities that is called as attribute. So here are attributes such as author ID, author name and author age. Here are some attributes such as book ID, book name and book type. Now in this author ID is the primary key, in this book ID is the primary key. Now here the relationship is also having an attribute that is called as booking date or publishing date. Like author publishes books, so what could be the publishing date? So basically these attributes are called as descriptive attributes. So whenever the relationship is having an attribute, that is called as descriptive attribute. So here there are two entities. a relationship between two entities. First entity is having some attribute or some characteristics. Second entity is also having some attributes and characteristics. There is one relationship that is also having an attribute such as publishing date or booking date. Now, what happens in real life is now, whenever we design a database or whenever we have been given some requirements and we design a database. So what happens is the first step is we get the requirements. Okay, these are the requirements. Second is we get the schema. So basically schema like person and the attributes or characteristics of person such as person name, person age, etc. Now from this schema we draw the ER model. That is basically the visual representation of data. And now after ER model there comes a relational model. That is basically from this visual representation we implement it in tables. And to do it physically we use a language to do the physical implementation. We use a language that is called as SQL. So this is the format which goes ahead. So now I have the requirement, I have the schema, I have drawn the ER model. Now I'll turn the ER model into relational model, that is into tables. So how I'll form the tables? So I'll pick the first entity, entity E1. I'll draw the table for author. Now for the author I'll mention all the characteristics. So basically characteristics are given in the columns. So author ID, author name, author age. Now I'll fill some data in here. Now here it is given that author ID is the primary key. So I'll mark author ID as the primary key. So basically this is the table for the author entity. Now coming to another entity, that is book entity. So this is the book entity and this is the author entity. So in the book entity also now I go ahead with the characteristics. I give them in the columns, book ID, book name, book type. Now I'll provide some random data for all these as of now. And then since primary key is book ID, so book ID is something which would be unique for every record. Here also author ID is something which will remain unique for every record. Now this table is done, this table is done. Now I am coming to the relationship table, that is reads table. So what will be there in the relationship table? So basically relationship table is something now which is establishing a relationship between two entities. This entity can alone tell me details about the author. This entity can alone tell me the details about the books. But I don't know now which author has published which book. So basically in the relationship table what happens is the relationship which is defined or which is established between two entities, we mentioned that. So how the relationships established, you may have learned about primary key and foreign key relationship. If you haven't, I have uploaded a video on the same, so you can go ahead and have a look. So basically I'll give the primary key of the author table here, I'll give the primary key of the book table here, and the descriptive attribute of relationship table, that is b date or b. This is not b type, this is b date. So this is b date. So I'll give the descriptive attribute, I'll give the primary key here, and I'll give the primary key here. Now these both would be acting as a foreign key. As I told, now what is foreign key? Foreign key is a key which take reference from primary key of another table, basically establishes a relationship between two tables. So foreign key is establishing a relationship. So in the relationship table, that is read table, I am taking a foreign key which is directly pointing towards the primary key of the author table, and then BID is a foreign key which is directly pointing towards the primary key of the book table. So basically they are establishing a relationship. So the very first question which comes in mind is, okay, what would be the primary key in the relationship table? Because in the author table, AID was acting as a primary key. In the book table, BID was acting as a primary key. But in the relationship table, which among these two would act as a primary key? So basically what happens now, this is a one-to-many relationship. One-to-many relationship means that one author can publish many books. So one author can publish many books. So basically A1 is an author which can publish B1 book. A2 is an author which can publish B2 book. A1 is again an author which can publish B3 book. So as I told, now one to many. So one author can publish many books. Either he or she can publish B1, B2 or B3. Now author 2 can publish B4, B5, B6. So one author can publish many books, but one book is published by only a single author. So if there is B4, it is published only by A2. If there is B1, it is published only by A1. So one author can publish many books, but one book is published by only one author. So what happens is ki author ID is something which can be repetitive, like author 1 can publish B1 book, author 1 can again publish B3 book, author 2 can publish B2 book. So what happens is ki you can see na ki there is duplicacy, or you can say ki A1 is repeating 2 times. For first time A1 is repeating for B1, second time A1 is repeating for B3. So A1 is something which cannot uniquely identify the records in the table because it is not unique. It is coming 2 times, maybe it can come 3 or 4 times. So what we do is ki generally in the many side, the primary key always lies. So what is the many side? Books is the many side. So one author can publish many books. So one author can publish B1, B2, B3, then other author can publish B4, B5. So basically one author can publish many books. A1 can publish B1 and B3. So book ID is something which is unique, but author ID is something which is not unique. So book ID is the primary key in case of the relationship table. So you can like just think in this way ki primary key always lies in the many side. So whenever there is a many side, the primary key would be lying only there. So book ID is the primary key. Now the second question which comes into mind is ki can we reduce these tables? So let's see about this. So this is the author table. This is the book table. And this is the reads table. Just now we knew that B ID is the primary key in the read table. Now author ID is the primary key here and B ID is the primary key here. So yes, the answer is yes, we can reduce the table. How we can reduce the table? So you can see now in this particular reads table and in this particular book table, the primary key is same. B ID is a primary key here. And BID is also a primary key here. So what we can do is we can combine these both tables and we can make one single table. So author would be a single table, that is one table, and book table along with read table can be a second table. So basically from 3 tables we have reduced to 2 tables. So when we will combine these 2 tables, what we will do is first we will give the primary key, that is BID, B1, B2, B3. Now we will start with the attributes. So B name is here, B type is here, now AID is here and B date is here. So basically the combination of these two can give me a table, and BID is something which would remain unique for both the tables. So BID will be coming one, and then these AID, B date, B name and B type would be there. So basically from 3 tables we have reduced to 2 tables. So just summarizing. So one-to-many relationship means कि whenever one entity is associated with many records in the other entity, that is called as one-to-many relationship. Now in one-to-many relationship, in the relationship table, primary key always lies at that side where there is a many relationship. So basically whenever there is 1 to n, consider that there is a customer and it has a relationship with order 1 to n. So where there is the n side, that is in the order side, the primary key will always lie there. Now the second thing is, can we reduce the table? Yes, we can reduce the table, because again in the relationship table, primary key is something which is common in the relationship table as well the entity table which is on the other side. So we can combine those tables. So from 3 tables we can reduce to 2 tables. As I explained about one-to-many relationship, it's just a reverse of that, but we would be discussing about some normal concepts like what would be the primary key, would the table be reduced, if the table are reduced, how many tables are in the final response, and many things. So without any further delay, let's get started. So many to one relationship. Let me just re-revise one-to-many relationship once again. So consider there is an entity E1 that is having a relationship with entity E2 in a one-to-many fashion. So what happens in one-to-many is E1 can be associated, like one record in E1, consider book. So book can be associated with many authors, A1, A2, A3. Now book B1, is associated with many authors. Book B2 can also be associated with A4, A5, A6. So when we simplify it, you can see B1 is associated with A1, B1 is again associated with A2, B1 is again associated with A3. So basically one book is associated with many authors. So this is one-to-many relationship. Now same in the case of B2, we can see B2 is associated with A4, A5, A6. Now again it is one-to-many relationship. Now in many-to-one relationship, it is just the reverse of the same. So in many-to-one relationship, what happens is that many authors can be associated with one book. So it's like author A1, author A2, author A3 can be associated with one book, that is B1. Now author A4, author A5, author A6 can be associated with one, that is B2. So basically it's a reverse of one-to-many relationship. So many-to-one is just a reverse of one-to-many relationship. Now let's understand from the definition. So a database model where multiple entities or records on one side of relationship are associated with a single entity or record on another side, that is called as many-to-one relationship. So let's understand from an example. So in the example, you can see that there is a entity employee, that is E1. There is an entity department, that is E2. Now E1 is having some characteristics such as EID, ENAME, EH, that is also called as attributes. E2 is also having some attributes such as department ID, department name, department type. Now E1 is having EID as the primary key. E2 is having DID as the primary key. Now according to this, many employees, just let me draw it here. So many employees can belong to the same department. So whenever you are working in a company, there is a department like such as development department, there is an HR department, there is some other departments. So many employees can work in the development department, many employees can work in the QA department, many employees can work in HR department. So many employees, that is N, can work in single department, that is 1. So when we simplify this, we get E1 is working in D1, E2 is also working in D1, just a second, E3 is also working in D1. So you can see that E1, E2, E3, that is many employees is working in the same department. So let me just write it here, E1, E2, E3 all are working in D1 department. Now we draw the tables for employee. Consider that this is the table for employee. We draw the table for department. This is the table for department. We draw the table for relation. So this is the table for relation. Now the relation table would be having the primary key of employee and the department. So it is having the primary key of employee, that is considered EID, and it is having the primary key of department, that is DID, which is now acting here as a foreign key, these both. Now the very first question arises, what would be the primary key in the relation table? So just think, what could be the primary key in the relationship table? So here from the diagram you can see that this is from the employee and this is from the department table. Now these both were present. Now you can see that employee E1, E2, E3. So employees are unique. So that is what this means is that employee can uniquely identify records in a table. Consider any attribute of employee. So it can uniquely identify records in a table. EID is something which can uniquely identify all the records in a table. But when I am coming to department, that is DID. So one department would be having one department ID. Consider that soft engineer is having E as department ID. HR is having H as department ID. So here you can see that every employee is working in E department. So whenever I am making a query in the database using key, okay, give me the employee who is working in E department. So again, it will give me many employees. But if I make a query key, okay, employee, give me the details about employee E1. So it will give me the specific details about that employee E1. But whenever I'm making query using the department ID, it will give me like any random employee, right? So what we do is we make this EID as the primary key. Also, you can like remember in such a way that whenever there is a many relationship on whichever side, that entity primary key is the primary key in the final table. So basically many side is always having the primary key. So in the many side, that is EID. Now the second question is that there would be 3 tables. Now can we reduce these 3 tables? Again the answer is yes, we can reduce the 3 tables because EID is the primary key here. And EID is also the primary key here. So 2 tables are having the same primary key. So we would just combine these 2 tables. So we would combine the employee and work, and department would be 1 table. So now 3 tables are reduced to 2 tables. So many to many relationship. As the word suggests, many to many means this particular entity would be also having many records here, and this particular entity would also be having many records here. So let's understand with the definition, and then we will jump in the example and discuss more concepts on this. So a database model where multiple entities records on one side of relationship. So consider that E1 and E2. So multiple entities and record of one side of relationship are associated with multiple entities or record on another side of relationship. Consider this as C1. Okay, so there is 2 entities, E1 and C1. So this is C1, C2 and C3. So where multiple entities or record on one side of relationship are associated with multiple entities or records on other side of relationship. So that is called as end-to-end or many-to-many relationship. So let's understand from an example. So consider that there are 2 entities, student and course. So according to this ER diagram, many students can opt many courses. So basically there are many students. Consider Ram, Raj, Rahul. For now I am only taking 3 students. So Ram, Raj, Rahul are the students, and the subjects which are present in the school are Hindi, English and Maths. Now coming to Ram, Ram can either opt Hindi, can also opt English and can also opt Maths. Raj can also opt English or Maths. Rahul can also opt Hindi or Maths. So basically Hindi is being opted by Ram, Hindi is being opted by Rahul. So you can see na ki in first go Ram is opting Hindi, English and Maths, and in the second go Hindi is being opted by Ram and Rahul. So at the first go we can see that there is a one-to-many relationship. At the second go you can see many-to-one relationship. So when they are combined, one-to-many or to one, so it results into many-to-many relationship. Now here you can see there are 2 entities, student and course. Student is having some attributes or characteristics such as student ID, student name and student age. Here student ID is given as primary key. So right now we are seeing that what requirements we are given. So all these things are given to us. So student is having attributes student ID, student name, student age. Course is having attributes course ID, course name and course professor. Relationship is also having an attributes such as enrollment date. Now they are having a many-to-many relationship among them. Student ID is the primary key for the student table. Course ID is the primary key for the course table. Now this is the visual representation of the DB. Now we will draw it in the form of tables, that is the relational model. Now first we will draw for the student table. So student is having student ID, student name and student age. I have given all the details, and student ID is the primary key. I have provided that. So student, that is a base table I have drawn. Now here for entity 2, course is the table. So course table is here. Now course is having attributes such as course name, course ID and course professor. So course ID, course name, course professor. Course ID is given as primary key. So this I have drawn as a primary key. Now for the relation table, I am having an attribute as enrollment date. So for now, just consider that I have given only this attribute in the relation table. Now what happens is from this particular table I am getting details about what is student ID, what is student name, what is student age. From this particular table I am getting details about what is the course ID, what is the course name, and what is the course professor. But I am not getting the exact relationship, because see, entity relationship, what happens is we establish relationship between entities. Now in these two entities which individually exist, we have to establish a relationship. And to establish a relationship, what we do is we pick the primary key from the first entity table, we pick the primary key from the second entity table, and in the relation table we mention both the primary keys. So from the primary key we can know okay, there is an employee E1 who is from department D1, there is an employee E2 who is from department D2. So all those details we can know from the relation table. So here I have given the primary key of student table, that is SID. Here I have given the primary key of the course table, that is CID. Now since this primary key, this key is kind of taking reference from the primary key of another table, so this is called as foreign key. This particular key is also taking a reference from another table, so this is also a foreign key. Now the very first question which arises in our mind is for this one we are sorted. For the student table or the base table we are sorted, SID is the primary key. For course table also we are sorted, that CID is the primary key. But when there is a relation table, what would it be the primary key in this particular case? So in this particular case, what happens now? I have told you that primary key always lies in the many side. But here though both are many, like the relationship is many to many. So where the primary key would lie? So as I told this is a many to many relationship. Many students can opt many courses, and many courses are opted by many students. So there is a many to many relationship. So student S1 can opt for course C1, student S2 can opt for course C2, student S3 can opt for course C3, again student S1 can opt for course C3, again student S2 can opt the C3 course. So you can see now what is happening is SID is also something which is kind of repeating. So you can see S1 is repeated here, S1 is repeated here, S2 is repeated here, S2 is repeated here, and here also C1 is here, C3 is here, C3 is again repeated, C3 is again repeated. So there is repetition. Yeah, I do agree that in the student table, student ID was acting as a primary key, and in the course table, course ID was acting as a primary key. But in this particular table, we can see that there is a repetition in the student ID as well and in the course ID as well, as many students can opt many course and many courses can be opted by many students. So what we do in this particular case is we make student ID and course ID combined as a primary key. So why we are focusing more on primary key? So whenever we are having a primary key, the query becomes very easy. So if you are having a primary key, you can just give that particular primary key and you can make a query key. Give me the details of student whose student ID is ABC or 1, 2, 3 or anything. So in this particular case, again if I give the student ID is 1, 2, 3. So student ID 1, 2, 3 has also opted C1 course, student ID 1, 2, 3 has also opted C4 course. So student ID is not something which can act as a primary key. Again CID is also something which cannot give me uniquely identified records. So what I do is I combine student ID and course ID in this particular relationship table to be a primary key, so that if I query using student ID and course ID, I can get the details for a particular student. I can get the student name who has student ID as S1 and who has course ID as C1. I can get the student name who is having the student ID as S2 and course ID as C3. So I can get to know about all the courses student has opted and what all students are present there. Like the query becomes much more easy and useful whenever we are having a primary key. So the first question was what would be the primary key. So in this particular case, the primary key would be the combination of both foreign keys or the primary keys from both the table. Now the second question which comes into our mind is can we reduce these tables? So in one-to-one, one-to-many and many-to-one relationship, we were able to reduce the table because in two tables the primary key was same. But here you can see SID is the primary key. Here you can see CID is the primary key. But here SID and CID, sorry, it's not BID, CID. So SID and CID are combinedly acting as a primary key. So the answer to this question is no. Be reduced. So the answer is no, the tables can't be reduced. So the total number of tables would be 3 and the primary key would be the combination of foreign keys, or you can say the primary key from E1 entity plus the primary key from E2 entity. So since we have completed all the mapping constraints, let's just re-revise once again in a very quick go that what are all these one-to-one, one-to-many, many-to-many and many-to-one relationships. So let's start from one-to-one relationship. In one-to-one relationship, what happens if the records in the first entity is associated with the records in second entity in one-to-one manner. That is, one record in one entity would be associated with one record in entity 2. So consider that there is a person and there is a PAN card. So for each person there would be one PAN card. So person P1 is having a PAN card as C1, person P2 is having PAN card as C2 and person P3 is having a PAN card as C3. So this is one-to-one relationship. The very first question is what would be the primary key of relationship table? So primary key can either be the one from the E1 table or primary key can either be the one from E2 table. So any one of them can act as a primary key. Now the second question is can we reduce the tables? So the answer is yes, we can reduce the tables and we can combine the tables. The two tables like the relation table and the table which is having the primary key same as the relation table can be combined and 3 tables can be modified into 2 tables. Now the second relationship is one-to-many. So whenever one record in the entity is associated with many records in another entity, that is called as one-to-many relationship. So consider person and mobile number. So one person P1 can have mobile number like can have many mobile numbers. So one person P1 is having a mobile number as M1 and one person P1 is also having a mobile number as M3. Now P2 is having as M2. So this is called as one-to-many relationship. Now again the same question, what would be the primary key of the relationship table? So the primary key would always lie at the many side. So mobile number is the many side. So a primary key would always be in the mobile number side. So primary key would be the one which is acting as a primary key in the mobile number side. Now second question is can we reduce the table? So as of now we have 3 tables. Person has mobile. So the first table, base table, then the second table, then the third table, relation table. Yes, we can reduce the table. So tables can be reduced. So primary key would be lying at the many side. So we can combine this has and mobile into 1 and person would be 1. So basically there would be 2 tables after reduction. Now the third one is many to one. Now many to one, again many books can have a single author. So B1 is also having author as A1, B2 is also having author as A1, B3 is having author as A2. So in many to one, again what would be the primary key of relation table? So the primary key of relation table, again the primary key which lies in the many side, that is the primary key in the book table, would be the primary key in the relation table. Again, can we reduce the tables? So there are 3 tables: book written by author. So primary key right now is lying inside the book, so we can combine this book and written by, that is this relation table, and we can combine it into 1. So there would be 1 table this and there would be 1 author table. So 2 tables. So we can reduce the number of tables. Now the last is many to many relationship. Again the example is student and course. One student can opt many courses can be opted by many students. So again this is a many to many relationship. The first question is what would be the primary key of relation table? So the primary key of relation table would be the primary key of student table plus the primary key of course table. So there would be a combined, or that is also called as composite key. That is 2 primary keys. Now second is ki can we reduce the table? So the answer would be no, we can't reduce the table, because again there is a composite key, there is a composite primary key. So since composite primary key is existing and for different entities there is only one primary key, so we can't combine the table, so reduction of tables is not possible. So why we are knowing about this participation constraint, ER, relationships, entities, attributes and much more things. So what happens now, ki consider in a very vague way. You have been given an API to design. So what you will do, the very first thing is ki you will know the requirements. Ki what are the requests of your API, what would be the responses of your API and much more things. Now second, you would be asking for a LLD diagram, that is a low level design diagram. Kyunki your API is internally calling this particular clients and this particular manipulations are done inside. So you will ask for the LLD. Once you get the LLD diagram, you would just implement the code and then the API would be working. In the similar way, what happens is ki whenever we are designing any database, we first get the requirements for the database, that what are the entities in the database, what would be their characteristics and much more things. Once we get all the entities, the primary key, the attributes or the basic requirements, we go ahead and draw the ER model using that entities, then establish a relationship between entities and draw all about the characteristic, the relationship and much more things. Now once we are done with the ER model, that is the visual representation of our API, what we do is ki we go ahead and draw the tables for that, that is the relational model. So we draw the tables for all that particular design or all that particular visual representation we had. Now for that particular tables to show in our laptop or to show in our database, what we do is ki we use a programming language for the same, that is SQL. So here also what we are doing is ki since we are knowing more about ER model, and as I told in the very end of this ER model series, or you can say in the very end of this ER model topic, we would be designing a model for Instagram. So basically whenever we are designing such a huge database, like Instagram is having such a huge database, or any social media or any delivery platform which is having such a huge database, they have many things, like they tend to use some of the best practices, they tend to use or they tend to do the code reusability, they avoid the data inconsistency and much more things. So here also comes into the picture the participation. Now what is the participation constraint? Let's go and understand. So from the definition, participation constraints in ER model define whether every entity in one group must be connected with at least one entity in another group, or if the connection is optional. So what happens in the participation constraint? As you know that in ER model we basically deals about entities and their relationship. Consider that there are two entities, they are having a relationship among them. Now what kind of relationship they are having? We have learnt about what kind of relationship they may be having, strong relationship, weak relationship, how they are internally mapped. We have learned about mapping constraints 1 to 1, 1 to many, many to many and many to 1. Now in this particular video we are knowing about what is the participation of that particular entities. So if two entities are together in a relationship, how they are participating? Is each record in one entity is participating with another record in present in another entity? So what kind of participation? So basically from the participation constraint you can understand from the word itself ki how entities are participating in the relationship. We deal about that in the participation constraint. So whether every entity in one group must be connected with at least one entity in another group, or if the connection is optional. So there are two types of participation constraint. One is total participation and second one is partial participation. So partial participation is called as optional, and total participation is this in which one entity in another group must be connected. So must be connected is the total participation and optional is the partial participation. So let's learn about these two participation. So the first participation is the total participation. So what happens in total participation? In total participation constraint, each entity in a participation set must be associated with at least one entity in the related entity set. So what it says is ki each entity in the participation set. So this is the participation set. And this is the related entity set when we are seeing from the department point of view. So whenever we are seeing from the department point of view, department is the participation set and employees is the entity set. Now here you can see there are two entities, employees and department. Employees having some attributes or characteristics in which EID is the primary key. Department is also having some attributes and characteristics in which department ID is the primary key. Now you can see here I have given a single line, but here I have given two lines. So basically these two lines means the total participation. So what it says is that employee works in a department. So every department would be at least having one employee. Consider that there are many departments, engineering department, HR department, sales department, and much more. Consider today I am making one more department, XYZ. So if there are no employees in this department, does this department makes any sense? So in the same way that in each department, there would be at least one employee. So department is having a total participation with employee, that in each department there would always be an employee. But it's not true that each employee would be working in a department. There could be some more employees which doesn't work in a department. They just come on a contract basis or something like that. So there could be a possibility that every employee is not associated with department, but every department must have a employee. In the same way, you can also take an example of this relationship. Consider that there is a customer who borrows loan. So there are two entities, loan and customer, and borrow is the relationship. Now every customer borrows a loan. So consider there are loans L1, L2, L3. So L1 may be associated with one customer, L2 may be associated with one customer, L3 may be associated with one customer. But there won't be any loan which is not associated with any customer. How come there is a loan for which there is no customer, right? So loan would always be having a total participation with customer. But for customer, there might be some customers who are not taking loan, who are not having any loans. So customer can exist individually or can have a partial or optional participation, that not every customer needs to have a loan, but every loan is somehow associated with one customer. So in the partial participation, in partial participation constraints, entities in the participating entity set may or may not be associated with entities in the related entity set. So if we are seeing from the employee's point of view, this is the participating set, and this is the associated entity set, or you can say related entity set. Now, not every employee from the participating set should be associated with related entity set. So not every employee should be present in all the departments or a particular department. Every department should have an employee, but not every employee should be a part of any department. In the same way, every customer can borrow loan, or loan is something which is associated with every customer, but there may be some customers who don't wish to borrow loan, right? So in this example, not every customer is borrowing loan. Some customers are borrowing loan, some customers are not, but each loan is associated with one customer, because there can't be any loan which is not associated with any customer. So these extended ER features comes into picture now, because what happens is sometimes when we are drawing the ER model or when we are drawing the entities, there might be a possibility that the structure becomes so complex. There is no code reusability. There is some data inconsistency which is also occurred. So to get rid of all these, to lesser the complexity, to increase the data consistency and much more things, we come with the extended ER features. So let's see about this. So again, the question is, why do we need? We design ER model for relationship between entities. Now in the real world, the data may exhibit some hierarchical relationships, and the EER, that is extended entity relationship model, provides the mechanism to represent these relationships accurately, which helps in code reusability, ensuring data integrity and consistency, and lowering the complexity. So in the real world, consider that there is a person. Now person may have some attributes such as name, age. Now this person may be acting different roles at different platforms or different areas. So this person may be a student. So student may have details such as student ID, student Aadhaar card or something like that, or student subject. Now this person may also be, when he or she is like doing some online shopping or doing some taking some orders or giving some orders, may also be acting as a customer for any of the website. So when the person is customer, it may have customer ID, customer order detail, and much more thing. So what is happening now? There is one entity person which is now being overburdened with all the attributes such as name, age. Now there is student Aadhaar, student subject, student ID, customer order ID. So what happens in this case now? We just split it into different subgroups such as customer and student. And now the attribute which is common among both, that is name. So name stays with the person. Just a second. Name stays with the person. Some attributes such as age, which is also common for person, customer and student. So it remains the same. But when we are coming to customer, there are some distinctive attributes which only customer have, student doesn't have. So such as customer ID. So customer ID stays with the customer, and for student, student subject. So in this way, what is happening now? We are subgrouping the entities into different entities. So these kind of things like hierarchical relationship which is being established. So you might have seen in inheritance that there is a superclass and there is some subclass. So in inheritance, what happens is the subclass or the child class inherit all the properties present in the superclass. In the same way, the person is having name and age, which is now inherited with customer and student. But now student and customer also have their distinctive attributes such as student ID and customer ID. So basically in this extended ER features, we would be seeing three features. First one is specialization. Second one is aggregation, and third one is generalization. Let me just give you an overview about all these three. Then we would be separately looking about all these three in details in next set of videos. So in specialization, what happens, as I told, that person may have some overburdened attributes because person may be acting as a customer, person may be acting as an employee, person may be acting as a student. So person entity all alone may be having many attributes. So what we do is we subgroup person entity into different entities, such as person may be subgrouped into customer, employee, student, so that the attributes are not overburdened to the person, and also customer, employee, student may have their distinctive attributes. So that is called as specialization. In this we do a top-down approach, and it follows the concept of inheritance. Now coming to the second one, that is aggregation. Now aggregation, from the word, it means aggregating something. So what happens in aggregation is sometimes there are some relationship which is ternary relationship. So more than 3 entities are involved, or n relationships in which more than 3 to 4 or 5 many entities are involved. So when there are involvement of more than 2 entities, or there are involvement of more than degree 2, then what happens na ki the structure becomes very complex. So when the structure becomes very complex, what we do is we aggregate the higher level entities, and then we establish a relationship between 2 entities. So in aggregation, what we do is we do an abstraction of the higher level entity into one entity, and then we establish the relationship. Again, if you're not understanding, no worries, we would be looking in depth about all these in the next set of videos. Now in the generalization, what happens? So in generalization, consider that there are 2 entities. First is the saving account, second one is the current account. Now this saving account and current account may have some attributes which is common among saving account and current account. So why not to make a generalized attribute, that is account, which would be having account number and account name, which is present in the saving accounts as well and current account as well. So basically in specialization, we are just identifying the subgroup entities. In generalization, using that subgroup entities, we are guessing the generalized attribute, generalized entity. Now, what is specialization? So, as explained in the earlier video, what happens is, consider there is an entity person. So, let's take an example of entity person. Now, person is an employee as well when it's working in a company, a student as well when it's working in or when it's studying in a college or school, and is a customer as well when he or she is doing some online order or online buying. So person acts as an employee, student and customer. Now what happens is ki person is having some attributes such as name, age. Now coming to customer, customer may have some attributes such as customer ID, customer order details. Now coming to student, student may have student ID, student subjects. Now coming to employee, employee may have employee ID, salary and much more thing. So what is happening now, this person entity is getting overburdened with many attributes. So what we do is we split or we subgroup the person entity into different sub entities such as employee, student and customer, and the attributes which are same in all these three, that is name and age, stays with the person, and the distinctive attributes which is not common among employee, student and customer such as employee ID, student ID and customer ID is provided to them. So what happens, specialization is, in specialization in ER model is like categorizing entities based on the common features. A super type group of entities with shared attributes and relationships, while subtypes have their own unique attributes, that is EID, SID and CID, and the shared attributes are name and age. So a super type group entities with shared attributes and relationships, while subtypes have their own unique attributes and relationship. It's a way to organize data efficiently. It is a top-down approach. So as you can see now, person is being subgrouped into employee and student. So it is a top-down approach. It is basically following the inheritance way, that there is a super class and there are some subclass which is inheriting properties from the super class. So let's understand from an example. So here it is a person. Okay, I just missed the last line. We have a relationship between the superclass and the subclass. So person is the superclass and employee and customer are the subclass. And there is a relationship, is a relationship between person, employee and customer. So person is the employee as well as customer. Now person may have some attributes, that is age and name, which is common among employee and customer, but employee ID, employee salary and customer email and customer IDs is something which is distinctive. So in the super type, all the attributes remain shared, which is like shared in the child classes also or the subclasses also, and in the subclass there are attributes which are distinctive. So this is specialization. Basically in specialization what we do is we subgroup the entities into different groups, like person is subgrouped into employee and customer. Person may have some attributes which is common between employees and customer, but employees and customer may have some distinctive attributes. So generalization. Generalization is like finding things that are alike and putting them into a bigger group to represent what they have in common. It helps making things simpler and organized. Now in specialization what we were doing is consider there is a person. Now we were subgrouping the person into customer, employee and consider student. Now in generalization what we do now, consider that we have these subgroups, student and employee. Now they may, student may have some attributes like name, age or something like that. Employee may have some attributes as well. So what we do is we make a higher level of entity, that is person, which would be kind of having the common things in student and employee. So in specialization we were identifying the subgroup entities, and in generalization we are identifying the generalized entity. So it is a bottom-up approach, as student and employee together are forming a person. So it is a bottom-up approach. We have is a relationship between the subclass and the superclass. So this is the superclass and this is the subclass. So let's understand from an example. So here in the example you can see there is electronic device. So consider that I have two entities. First one is mobile phone and second is laptop. Now mobile phone may have some attributes and laptop also may have some attributes. So consider mobile phone is having an attribute such as battery. Mobile phone may have memory. Then it may have mobile ID and it may have the mobile type. In the similar fashion, laptop may have laptop ID, laptop serial number. Again, laptop also would be having an attribute such as memory and battery. Now you can see memory and battery is an attribute which is common in both of these, mobile phone and laptop, and it is a general attribute of an electronic device. So what we do is we make a generalized entity, that is electronic device, which would be now extending battery as well as memory, and we remove this battery and memory from here, and we remove this battery and memory from here as well. So what we did is we generalized some of the attributes which was common in the sub entities. So this is what we are doing in this diagram as well. There is a electronic device, laptop and mobile is having a relationship with the electronic device, as it is a bottom-up approach. Electronic device is now having memory and battery, and laptop have their distinctive attributes such as laptop serial number, laptop ID, and mobile type. So this is generalization. So basically in the specialization, what is happening in the specialization, we have an entity and we provide some subgroup entities which have some distinctive attributes. In generalization, what we do, there are some subgroup entities which are having some common attributes. So we make a higher level of class, or we do an abstraction of a higher level of class which would be having all the common attributes or common characteristics these two would be having. So there is one more thing in extended ER features. First one is attribute inheritance and second is the participation inheritance. So in attribute inheritance, what it says is that both specialization and generalization exhibit attribute inheritance. What is this? Consider there is a person who is having some attributes. So employee and student who is inheriting person would be having the same attributes. So it inherits the same attributes. In participation, what it says is if parent is participating in some relationship, so child would also be participating in that relationship. So consider person is a parent and employee and student is a child. So if parent is participating in any relationship, employee and student would be participating in the same. Now there is one more feature of extended ER, that is extended entity relation, that is aggregation. Now let's understand what aggregation is all about. So aggregation is like stacking things on top of each other to create a structure. It is used to create a hierarchical structure in data modeling, showing how a higher level entity is composed of lower level entities. So basically in aggregation, what happens now? We have heard about relationships and types of relationship, like binary relationship, ternary relationship, and more. Like if more entities are involved, then there are more relationships. So what happens now? Whenever there are more than two entities which are being involved, there is a complexity which is increased very much. So when the complexity increases, it's very difficult to understand the ER model as well. So what happens whenever there is a ER model which is extending the degree to, or extending or being a ternary relation or more complex than that, what we do is we generally create a hierarchical structure showing how a higher level entity is composed of lower level entities. So what we do is with that lower level entities, we make a higher level entities and try to generalize or try to make it in such a way that it again comes in a entity to entity relationship. So this may sound confusing right now. Let's understand from an example first. So abstraction is employed to view relationship from a more general perspective, focusing on a higher level entity. So we basically use the abstraction concept and we make the lower level entities as one entity, which is a higher level entities, and in that higher level entity there is a relationship among different entity. So this is the ER model which is present before aggregation. So there is an employee which works in a department, is also having a job, and now this employee also manages a department because this employee is a manager. So consider there is a company. Now in company there are many employees. Some employees are developers, some employees are QA person, some employees are HR person, and there is a manager who manages a particular branch or a particular department in a company. Now that particular manager is also serving as an employee. That particular manager is also having a job. That particular manager is also managing the department. So what is happening here is that employee is working in a department, is also having a job, and now employee is managing the department, that is called as manager. So you can see that there are many entities involved and this ER model is kind of complex. So what we do in aggregation is that we combine these lower level entities into a higher level architecture. So in a higher level, what we do is that we segregate all the lower level entities into one complex architecture. So we segregate all the lower level entities into a high level architecture. Now what it shows is that employee works in a department, is having a job, and employee manages as it is a manager. So basically what we are doing is that we are segregating all the lower level entities into a higher level architecture, and then we are establishing the relationship. So this whole is treated as entity 1 and this whole is now treated as entity 2. So there is a relationship between entity 1 and entity 2, that is entity 1 manages entity 2. So basically manager manages the department in which manager is also working as an employee and having a job. So in aggregation what happens is that whenever there is a relationship or whenever there is a ER model in which the degree is extending to, what happens, there is a complex architecture. So just to break down that complex architecture into some simple architecture, what we do is that with that lower level entities, we combine all the lower level entities into one higher level architecture, and then we establish the relationship as we establish between two entities. So steps to draw an ER model. Till now we have learned all the things about ER model, like what are entities, types of entities, strong, weak, then types of attributes, complex, composite, multi-valued, then coming to the relationships based on cardinality or degree, that is ternary, binary, and much more, based on mapping constraints, that is 1 to 1, 1 to many to 1, and many to many, then about total participation and partial participation, then extended ER features. All of things we have known. So we would be knowing about how we can draw an ER model. So the very first step is recognizing the entities. Now consider you have given a problem statement that you have to draw an ER model for Myntra app. So you have to identify all the entities which are there. So the very first step is recognizing all the entities, such as if you are drawing an ER model for library. So there would be some library department, there would be some book type, there would be an entity of book, there would be an entity of details, there would be an entity of all the details of when you are publishing the book, when you are returning the book, and much more things. So there would be some entities, so you need to identify all the entities. Now the second thing is that when you have identified all the entities, now you need to know all the characteristics or all the attributes of that particular entity. Consider again taking that library example, there is a book. So book may have book ID, book author, book issue date, book submission date, and much more things. So we need to specify the characteristics or identify the attributes. Now the third step is discover connections and relationship, also constraints like mapping and participation. Now we need to discover the relationship that library has books. So there is a has relationship, that library has books. Now there are some mapping constraint that what it would be the relation 1 to 1, 1 to many to many, or many to 1. What would be the participation constraint? Either is it a total participation or is it a partial participation? Now in the fourth, we are defining the connection types, that how entities are connected or cardinality. Again, based on degree or the mapping constraints, we identify that if it's a one-on-one relationship, one to many, many to one, many to many, total participation and partial participation. Now in the fifth way, what we do is now we construct an ER model. Now we are ready to construct an ER model. We got the entities, we got the characteristics, that is attributes, we got the relationship among entities. Also we got that what kind of relationship they have, what kind of participation they have, what kind of mapping they have. Like we got all the details. Now we can go ahead and design the ER model for the same. So construct an ERD, that is entity relationship diagram. Now the sixth step is annotate relationships and attributes. So there may be a possibility that there is a derived attribute which would be represented like this. There may be a possibility that there is an attribute which is a primary key which would be represented by this. There may be a multi-valued attribute. There may be a composite attribute. So we have to annotate the relationships and attributes. The seventh step is review and refine the model. So again, you can use that extended ER features whenever you are seeing that the complexity is increasing. You can use that extended ER features, that is specialization, aggregation and generalization. Now document the model. So you can also go ahead and document the model, that what all things you have done. Like you can document that library has a relationship with books. Books has a relationship with the details, or books has a relationship with students who are taking the books, like these. So you can document all the relationships which books have, which library has, which student has, in a proper documented format. Now you can validate that document with the stakeholders, that is my understanding correct, that there is a one-to-one relationship. The entity is having three attributes, among which one is the composite attribute, and the relationship is one-to-one or one-to-many, like this. And the 10th step is implement the database schema. So now you can go ahead and implement the database schema, or you can go ahead and formulate the relational model or formulate the tabulated model for the same. Before moving forward, I would like you guys to know what Instagram is. So yes, it's a lame question because 99.99% of the people would be knowing about Instagram. But just for the people who are not knowing, or just to give you a short revision about it. So Instagram is basically a social media platform where you upload your picture, where you upload images, videos, stories, have friends like followers, then you follow your friends, which is called as following, then you upload your profile picture, then you have some bio, and there are much more things which is there in Instagram. So Instagram is a social media platform that allows user to share photos and videos. Now, what all things are there in Instagram, or what all things we can do on Instagram? So the first thing is creating our own profile. So everything starts with creation of a profile. So we create our profile, then we add a profile picture and some details like your bio, that where you are working right now, or if you are a musician, you can mention that you love playing music or singing, or you love playing guitar, and much more things you can mention. Now the third thing is connection with your friends, or connect with your friends. So basically on Instagram, whenever you are done with the profile creation and whenever you have uploaded your picture and some bio about yourself, then you can start connecting with people. You can upload a post, you can like and comment on different posts, share stories, and much more things are there. So why right now I am explaining about this is because I want you guys to have a basic idea about how Instagram functions, what all things we can do on Instagram. On basis of this, we would be formulating an ER diagram. Now, let's start with all the steps which are needed to draw an ER diagram. So the steps which I told you in the last video, we would be going step by step and we would be formulating an ER diagram. So there the step 1 was recognizing all the entities. So here the entities are user profile. So user might be having a profile. I told na ki firstly what happens is ki user create a profile. So there is a user profile which is created. So user profile is the first thing. Now when the user profile is created, he or she will upload the profile picture, add some details about them, and then will start connecting with friends. So the second thing is user friends. So the second entity here is user friend. Now the third entity is we have created a profile, we have connected with our friends, now we would like to upload some photos or videos. So the third is user post. The fourth entity is user login. So whenever you go to any social networking platform like Facebook, LinkedIn, Instagram, so there you get a login page where you enter your username and user password, and then you are redirected to that particular social media platform where you can see your profile and timeline as well. Now the fifth entity is user likes. So if you upload your post, there might be some people who would be liking your post. If you are connected with some of your friends, you would also be liking their post or commenting on it or sharing it on different social media platforms or sharing it on your story and much more things. So these are the 5 entities. As of now, I have taken these entities into consideration because again, if I increase the number of entities, the ER model diagram would be very complex and it's not impossible to include all the entities, all the attributes in the same model or in the same diagram. So as of now, we are seeing a template which we can follow for a ER model of Instagram. So these 5 entities are right now recognized as the entities which we can use further in the ER model. Now the second thing is specify entity characteristics or attributes. Now we have specified that what all entities are there, like user profile, user friends, user login, user post, user likes. Now we need to identify what are the attributes or what are the characteristics of that particular entity. So first we'll start with user profile. So in user profile, there is a user ID, there is a username, there is an email, and there is a profile pic. Now user ID is serving as a primary key because it can uniquely identify records in a table. The second is username, which is a composite attribute. So composite attribute, what it means, ki username can also be further divided into sub attributes like user first name, user middle name, and user last name. Email is a single valued attribute. Profile picture is a single valued attribute. DOB is a stored attribute. Stored attribute again is something which is stored, and derived attribute is something which we derive from the store attribute. So here user ID is the primary key, username is the composite attribute, email is a single valued attribute, profile pic is a single valued attribute, DOB is a stored attribute, and age is a derived attribute. Now coming to entity number 2, that was user friends. Now user friends have these attributes such as follower ID, follower name, and user ID. Now you can see user ID, you have seen that user ID in the user profile as well, right? And it is present here as well. So there is some kind of relation which is present between user profile and user friends. So if a primary key of one table is present in another table and referencing it, that is called as foreign key, which we have learned in the last videos. So we would be having a good look on this in the ER model diagram. Right now, consider that user ID is right now acting as a foreign key, which is referencing to the primary key of the user profile. Now user friends is having a follower ID which is serving a primary key for this particular table. Now follower name, which is a single valued attribute, and user ID, which is also a single valued attribute. Now the third entity is user post. Now user post is having a post ID, a caption about the post, or if you post any image then there would be a caption, image, video, likes count, and timestamp, the time at which you have uploaded your picture or the time at which you have posted your picture or videos. So post ID is acting as a primary key for this particular user post table. Caption is a single valued attribute. Image is multi-valued because you have seen that sometimes in one post there are many images. So there could be many images which could exist in single post, so that is why it is a multi-valued attribute. That is, one attribute may have multiple values or multiple things. So video is again a multi-valued attribute. Likes count is a single value attribute. It would be in numbers like 1000, 2000. Timestamp is also a single valued attribute. Now coming to the fourth entity, that is user login. Now user login is having a login ID, login username, and login password. Now in this, the login ID is serving as a primary key, the login username is a single valued attribute, and the login password is a multi-valued attribute. So coming to the fifth attribute, this is fifth, is the user likes. So user likes is having a post ID and user ID. So here post ID is serving as a primary key and user ID is a single valued attribute. So now you would be seeing there are some of the attributes which are being repeated in some of the tables, like user ID is also repeated. Post ID is something also which is repeated in the user post and user likes table. So again, there is a repetition of attributes because these attributes are somehow serving as a primary key in one of the table, and in other table to establish the relationship they are serving as a foreign key. So what foreign key does is that foreign key help us to establish a relationship between two tables. When we go forward in the video, you would be having a more better understanding. So for now, just you can understand from this way ki if you are seeing some repetition of attributes in different tables, so there could be a possibility that one table is having a relationship with different tables. So in that different tables, there is a attribute which is present, which is serving as a primary key in table A, and right now is serving as a foreign key in table B, table C, or table D. Now the step 2, discover connections, relationships, also constraints like mapping and participation. Now we have to discover the connections and linking or the relationship between them. As I told like right now only na, ki what happens is ki we use the primary key to establish a relationship between two tables. Now we have also learnt about the relationships, like types of relationships based on cardinality or mapping constraint, that is one to one, one to many, many to many, and many to one. So on the basis of that, we will now establish the relationship between those entities. So the very first step was to identify the entities. The next step was to identify the attributes or the characteristics of all those entities. And the third step is to establish the relationship between the entities, to know the mapping constraints, like how they are mapped with each other, one to one, one to many to many, or many to one. Now here, the first relationship is user profile will have user friends. So n number of profiles can have n number of friends. Now the second one is user profile have user post. That is one user profile can have n number of posts. So that is 1 to n relationship. That is user post will always be associated to user profile. Therefore, there is a total participation. I also explained about types of participation. You can have a look on the earlier videos and then you can come and have a look on this particular video. So the third one is user profile has user login. Now one user profile always have one user login. So consider that there are two profiles which is created. One I have created, one my sister has created. Again, my sister would be having different username and different password. I would myself be having different username and different password. So there is a one-to-one mapping. Now the fourth is user profile has user likes. So one user profile can like many posts, like there are many friends of mine, so I'm liking every post uploaded by them. So one user profile can have number of likes, like many number of likes. So user likes will always be associated to a user profile. Therefore, there is a total participation. Now the fifth is user friends have user post. So user friends can also upload some post, right? So user can consider that there are multiple user profiles. User profile 1, user profile 2, user profile 3. User profile 1 and user profile 3 are friends in, like they both are friends. So user profile 1 can also upload many photos. User profile 3 can also upload many photos. So user friends may have user post. That is 1 to n relationship, that one user friend can upload many posts. So it will also be associated to a user profile, therefore total participation. So why this total participation term is coming every time? So what happens now, ki there is a user friend, right? So if there is a user, only then a user friend would be existing. If there is no user, then user friend is associated with whom, right? So user friend is existing only when there is a user which is existing. So therefore there is a total participation. Now user friends has user login. So user friend can also have a user login. Again, it would be in a one-to-one manner, because one user friend can have a one user login. Another user friend would be having another user login. So it is one-to-one fashion. Now seventh one is user friends has user likes. So user friend can also like other photos, can like their own photos, can like other friends photos as well. So that is 1 to n relationship. And again here user likes will be associated to a user profile, therefore total participation. So again, if there is no user profile which is existing, then user likes doesn't make any sense. So there should be at least one profile which should be existing so that we can count the user likes. Now this is the ER model of Instagram. I know it is a bit complex, but let's understand from the very beginning. I'll make sure that you understand each and everything, and even if you don't, please watch the video again and the steps to design an ER model video as well, because that video is also very important video in terms of understanding. Again, there are terms like total participation, strong entity, weak entity, multi-valued attribute, composite attribute, that wouldn't make any sense if you don't watch the earlier videos. So first watch all the earlier videos and then you can come here and then have a look on the ER model of Instagram. So let's start. So let me just switch it to this one. Okay, so we will start with user profile. Now user profile is an entity. User profile would be having username, user ID, email, profile pic, DOB and age. So here I have mentioned it. So the user profile is having user ID, username, email and profile pic. Now user ID is serving as a primary key, so we have underlined this. Email is a single valued attribute, profile pic is a single valued attribute, age is a derived attribute and DOB is a stored attribute. So in this way we represent the stored and derived attribute. And here username is serving as a composite attribute. So when there is a composite attribute, it is an attribute which can be breaked into subparts. So username is now breaked into first name and last name. So this is about the user profile. Now user profile has some relations. So the very first relation is user profile have user post. The second relation is ki user profile has user likes. The third relation is user profile has user login. So first start with user profile has user login. So now user profile has user login. Every user would be having only one login details. So there is a 1-to-1 relationship. Now user login is having some of the attributes such as login ID and login name. Login ID is here serving as a primary key. Now coming to the second relation, user profile have user post. So user profile have user post. So user profile, one user can have multiple posts, right? So there is a 1-to-n relationship between them. And in the user post here you can see there are some of the attributes such as post ID, image, timestamp, video and caption. Now caption here is working as a single valued attribute. Video here is right now a multi-valued attribute. Why so? Because multi-valued attribute is an attribute which can have multiple values. So there could be multiple videos for a single user, right? So in the timeline you can see for a particular user you can find multiple videos and multiple images. So here video is working as a multi-valued attribute. Image is also serving as a multi-valued attribute. Timestamp is a single valued attribute and post ID is here serving as a primary key. So we have made it underline. Now coming to the third relation user profile has. So user profile have user friends. Now you can see that I have made it two rectangles. Why so? Because here the user friend is a weak entity. So we have read about strong entities and weak entities. Why user friend is a weak entity and why a user profile have user friends is a weak relation? Because if there is no user, there wouldn't be any user friends, right? So it all depends on user. If there is no user, there won't be any user post, there won't be any user likes, there won't be any user logging or something like that. So for now, just to make you or to give you more clarity about weak and strong entities and weak relationship, I've used this here just for an example, right? So when you are asked to draw an ER model in the interviews, you can go ahead with the basic template only, but when they ask you to specify everything like the strong entity, weak entities, total participation, partial participation, then you can go ahead and point out everything that this is a weak entity, and you can give an explanation why this is a weak entity. So again, user profile and user friends have a end-to-end or many-to-many relationship, because many user profiles can have many friends. Same way, many friends can have many user profiles. So here user friends is having a user ID and follower name. Now you can see user ID which is present here as well and here as well. Here user ID is working as a primary key in user profile table, and here user ID is somehow establishing a relationship between user profile and user friends. So it is acting as a foreign key which is helping to establish relationship between user profile and user friends. Now user profile have user post. This I have explained. So this relationship is explained, this relationship is explained, this one is explained. Now coming to this relationship. So now user profile has user likes. So again, a user profile can like many posts or can have many posts which can be liked by a particular user. So that is one-to-many relationship. Now user likes is also having one user ID which is serving as a foreign key which is helping to establish relationship between user profile and user ID. And user like is also having a post ID as a primary key. Now again, user post can also have user friends, like user friends can also have user posts. So there is 1-to-n relationship between user friends and user post. User friends can also have a user login. So there is also a 1-to-1 relationship between user friends and user login. And I guess, yeah. So user friend can also have a user likes. So there is also 1-to-n relationship, that is one friend can have many likes. So there is 1-to-n relationship between them. So this is all about the ER model of Instagram. Again, it is very complex to understand, but right now I have taken very less entities and very less attributes to make you understand it at a very clear picture. If you're asked in an interview to draw or design an ER model of, consider Facebook, consider LinkedIn, or consider Threads, so you can use this particular ER model as a template, but always think about all the important entities which you shouldn't miss, because again there are many entities and you can't take all the entities, all the attributes and draw an ER model. You have to pick some of the few of the entities which are important according to you, few of the attributes, and you have to draw an ER model. Also do take care to follow all the design patterns, like if there is a multi-valued attribute, there would be 2 circles. If there is a derived attribute, there would be a dotted circle. If there is a weak relation, then there would be 2 diamonds. If there is a weak entity, then there would be 2 rectangular boxes. So always make sure to mention all these, because all these things would really help you and the interviewer as well to understand that you have a very great knowledge about ER model and DBMS. So we read about ER model in the last set of videos. Now here we would be knowing much more about the relational model. Now why we are knowing about all these models, how it is helping us, and why we should be knowing about relational model, tables, relation, and much more thing. So what happens now? You are given a requirement. Consider you are given a requirement that you have a banking system. Okay, so now what you will do is, firstly you will draw the ER model for the banking system. Now secondly, you will convert this ER model into relational model. So in the ER model, we basically deal with the visual representation. And in the relational model, we deal with the tabular representation. And when we are done with the relational model, we will choose a software using which we can insert all the data, do some manipulation on that data, or perform some CRUD operations. So this is how the flow goes. Now in this particular video, we are learning about relational model. So what is relational model? It is a way of organizing data into tables. Now what happens is, consider there is a banking system. Now for that banking system, I have given a visual representation of that banking system using all the entities, all the attributes. Now from that visual representation, what I am doing is I am using that visual representation to convert it into a tabular format. So basically conversion or organizing data into the form of tables is called as relational model. Now there are some terms which are mostly used in the relational model. The first one is table, which we called as relation in the relational model. The second is row, which we called as tuple in the relational model. The third is column, which we called as attribute in relational model. The fourth is record, which is each row in a table. The fifth one is domain, which is the type of value an attribute can hold. Sixth one is degree, which is the number of columns in a relation. And seventh is cardinality, which is the number of tuples. Let's understand from an example. So this is a table. Now the table would be having some rows and some columns. So the columns are called as attributes in the relational model. The rows are called as tuple. And each row is called as record. Now the table itself is called as a relation. Now domain. So consider that this is the attribute which is name. Now name can only have character values. Consider this is the attribute which is age. So now age can only have integer values. So we are giving the domains of both of the attributes. Now the sixth is the degree. Degree is the number of columns in a relation or attribute. So you can count 1, 2, 3. So the degree here is 3. And cardinality is the number of tuples or the number of rows. That is 1, 2 and 3. So cardinality is also 3. In the ER model, cardinality basically means the mapping constraint that was 1 to 1, 1 to many to many and many to one relationship. But in the relational model, cardinality basically means the number of tuples and degree basically means the number of columns. Now, what is relational model all about? So, relational model is all about data being organized into tables, establishing relationship between tables using foreign key as I explained earlier, maintaining the data integrity, that set of rules should be there that if there is a attribute which is called as age, in that attribute I shouldn't fill the value as ABC. So there should be some integrity constant which should be present, and there is a domain that is integer. Only integer values are accepted here. If I insert other values apart from integer, it will give me an error. And then the fourth one is a flexible and efficient way to store data which is using the SQL and to retrieve data. So these all four things combines gives us the information about relational model. Let's have a look on what all are the things we take care in the relational model. So the first thing is maintaining the integrity constraints like domain, entity and referential integrity. Now consider that there is a table person. Now person is having attributes as name, age and date of birth. Now there could be a possibility that someone inserts a wrong value in the age. Consider ABC. So there are some integrity constraints which make sure that we don't insert any data apart from the domain. Now the second is the value should be atomic, that can't be divided further. So whenever we give the attributes or whenever we provide the attributes in the relational model, that all the values should be atomic. It shouldn't be that I am giving a multi-valued attribute in a table. So if I am giving a multi-valued attribute, consider that there is a username which is a multi-valued attribute. So while making the table, I shouldn't give it as username. What I can do is I am making the table and here I'll give the user first name, here I'll give the user second name or middle name, and there I'll give the user last name and then the other attributes, which means that all the values should be atomic, that it can't be further divided. Now the third is each row must be unique, and here the keys comes into picture, that is candidate, super and primary. So converting an entity relationship, that is ER model, into a relational model involves several steps. So let's start with step 1. Step 1 is identifying the entities. So first, list down all the entities like the strong entity and the weak entity. In the entity video, I told you about the strong and the weak entity. So you can go ahead and watch that particular video. It would be, I guess, like it would be 10 lectures behind. So you can have a look on that. For your convenience, I'll give the link in the description itself. So here you can see that there is a ER model of a person which is having a relationship with address. Now the person is having some characteristics or attributes, that is ID, name and age. And here ID is acting as a primary key for the person table. Now person is a strong entity. Coming to address. So address is having attributes such as city, flat number and street. Here address is a weak entity. Why address is considered as a weak entity? Because consider that there could be a situation that there is no person. So if there is no person or there is no existence of person, does address plays any role? In a similar way, like there is student and there is a course. If there are no students who would be taking the course or who would be studying in that department. So basically address here is serving as a weak entity and person here is serving as a strong entity. Now when there is a relationship between strong and weak entity, that is called as weak relationship, which is indicated by double diamond, and whenever there is a weak entity, it is indicated by double rectangles. So what happens is that when there is a strong entity, we mention all the attributes of the entity to formulate into a tabular format. So basically person would be a table which would be having columns like ID, name and age, where ID is serving as the primary key. But in case of address, which is a weak entity, what we do is, since strong entity and weak entity are establishing a relationship between them. So I've told you earlier what happens is that whenever we need to establish a relationship between two entities, we use the foreign key concept. What does foreign key does is, the foreign key is a key which helps to establish relationship between two tables. It serves as a primary key in the table A and it serves as a foreign key in the table B. So whenever table A and table B wants to have a relationship between them, what they do is, if table A is having a primary key, it took that primary key and make it a foreign key in table B, so that table A and table B have the same attribute which can help to form a relationship between these two tables. Now in address table, what we are doing is, we are mentioning the primary key which is from table person. Then we are giving all the attributes such as flat number, street and city. Here flat number is acting as a primary key. Generally in weak entities there is no concept of primary key because again the entity itself is weak, but there is a unique identifier and we called it as primary key. So here ID plus flat number both would be acting as a primary key, because ID here is acting as a foreign key which is referencing to the primary key of another table, and flat number is acting as a primary key for this address table. So basically there is a composition of ID and flat number, that is why it is called as a composite key. And this composite key is serving as a primary key for the address table. So whenever we would be making a table for both of these entities, strong and weak, in the strong entity we would be giving all the attributes along with the primary key. In the weak entity we would be giving the attribute which is a foreign key which references to the primary key of strong entity table. Along with that we will mention all the attributes, and the primary key for this table would be a combination of the primary key of this table and the foreign key of this table. So now the step 2 is identifying the attributes. Now again I told you that attributes can be of many types like stored, derived, single valued, multi-valued, composite. So whenever there are such type of attributes in ER model, how we will go ahead and design it in a tabular format. So first thing what we will do is we will differentiate the entities. When we differentiate the entities, per entity there are some attributes or there are some characteristics for that entity. So consider that this is the ER model where we are talking about employee and department. So they have a relation that employee works in a department. Now employee is having a composite attribute, that is name, which is further divided into first name and last name. Employee is also having a multi-value attribute, that is phone number. So one employee can have two phone numbers, primary or secondary. And here ID is serving as a primary key. Then there is a department which is having department ID as the primary key for this particular table, and department name as a common attribute or a single valued attribute. So let's take the case of name, which is right now serving as a composite key. So what we will do is ki whenever there is a, okay, just a second, I guess I have named it wrong. So this would be a composite attribute and this would be a multi-valued. Okay. So coming to the composite attribute. So consider that this name is a composite attribute. Now whenever we want to draw a table for this employee, what we will do is we will mention this employee. Now we will start mentioning the attributes, that is ID. Now for this composite attribute, what we do is we mention all the composite attributes, because again in relational model what I have told you ki value should always be atomic. There shouldn't be any value which is not atomic. There should be only atomic values which can't be divided further. So here the last name and first name we are giving as it is, employee first name, employee last name. So we have eliminated this attribute name with employee last name and employee first name. Similarly, if there are any more composite attribute, we will eliminate that particular attribute and we will mention all the sub attributes. Now coming to the multi-valued attribute, that is phone number. Now in phone number what we will do is there would be a table with all these things, ID, employee name, employee last name and everything. Along with that there would be another table, because in multi-valued attribute what happens is we are saying that one employee can have different number. So consider that I am formulating this in a tabular format. So there is an employee ID and there is a phone number. Okay. So consider that there are employee IDs 1 and 2. Now I am saying one is having a number 919 and one is also having a number 929. So again I can't put the attributes like this because this row should have only one value. So either it will lead to the duplicacy, that I am again duplicating employee ID and here I am giving 929 rather than here, or else what I can do is I can make a separate table where I can give the employee ID and the phone number. So here what happens is this table will remain the same with ID, employee first name and employee last name. But for the multi-valued attribute, what I will do is I'll make a new relation with the primary key which is present here and the attribute which is a multi-valued attribute. So there would be a new table for the same. Now the step 3 is the key selection. Choose the primary key for each table. For some it can be in a form of composite key, as I told in this example of weak entity, where the primary key is in the form of composite key, that is composition of keys. Now the step 4 is if entities have a relationship, break it down and reduce the number of tables if possible. So you have seen in the last video where we made an ER model for Instagram. So there you have seen that there were many relations between user post, user profile, user friends. So basically there are one to one, one to many, many to many and many to one. On this I have made a video that what happens that if there are two tables which is having one-to-one relationship. So can we reduce that tables? If the tables can be reduced, where the primary key would exactly lie. So again, if there are two entities and they have a relation between them, there would be 3 tables. First one would be entity 1 table, second would be the relation table, and third would be the entity 2 table. And what happens was entity 2 table or the relation table combines sometimes entity 1 table and relation table combines. So about this I have made a dedicated video, you can have a look on that as well. So whenever there is a one-to-one relationship, there would be 2 tables and primary key can lie on any side. So consider that there is a relation between employee works for department. So when there is a one-to-one relation, so there would be 2 tables for employee and department and third table for relation. Now consider that there is a one-to-one relation, so there would be a employee ID which would be acting as primary key here. There would be a department ID which would be acting as a primary key here. So for the relationship table to deduce, what we do is we combine these 2 tables or these 2 tables, any of the table we can combine and we reduce it to 1 table and there is 1 table. So basically 3 tables are reduced to 2 tables. Now when there is one-to-many relationship, so whenever there is a one-to-many relationship, what happens is primary key always lie into the many side. So relation table and the many table always combines and the this table remains the 1 and these 2 table combines into 1. So there is again two tables where primary key lie on the many side. Now when there is a many to one relationship, just reverse of this, two tables and primary key can lie on many side. When there is a many to many relationship, three tables would be there, because again this table may have some attribute which is associated with this table, and this table also may have some attributes which is associated with these tables. So there is no common thing between them. So there would be a three tables, and primary key always lie in the relation table, which will be a combination of primary key from this particular table and primary key from this particular table. So this was all about this video. I hope you like this video. So if you like this video, please hit the like button. If you are someone who is new to my channel, go ahead and watch the tech content first, and then you can go ahead and subscribe. If you are someone who is very new to DBMS, can surely binge watch this series, because this is very beginner friendly series and everything is taught from very basics. Till then, take care, keep learning, keep growing, keep smiling. Bye all.